A short day began, with a low hum that belonged to the planet itself. Rotation hurried the light across cloud decks that already looked tired from working all night. Dawn did not pour. It advanced in pains, as if someone tilted mirrors toward the sea. The sun was weaker in output, not in temperament, so the atmosphere learned to keep what it received. Layers of vapor and aerosol stacked into a shield that dulled color and deepened glare. The blue that would later define a normal sky was stifled by fine particles and by gases that scattered light into a metallic wash. On some mornings, the horizon carried a faint saffron fringe where photochemical haze thickened, a sign that sunlight had been busy unthreading methane and knitting it into small solids that hung like dust. The air had gravity's full attention. Pressure ran higher than modern habits, thick enough to slow sound and give thunder a rounded body. Nitrogen did most of the lifting. Carbon dioxide added weight and purpose. Steam wandered in sheets that condensed into cloud towers when uplift whispered permission. Oxygen was a trace, more rumor than presence, unable to rust iron or carry fire. Under this canopy, ultraviolet light arrived with a ferocity that would later require warning labels. Where haze thinned, UV wrote its signature into every exposed film and pool. Where haze thickened, sunlight softened into honey and kept its bite for another day. Wind worked with rotation and built grand structures that stretched from horizon to horizon. Coriolis turned rising columns into spirals and laid storm bands along belts that matched latitude. Between the belts, air sank and cleared brief corridors where distance grew sharp and the sea looked almost black. Shear lines gathered at the edges of these corridors and spawned vortices that traveled like thoughts someone tried to ignore. Cloud anvils rode these lanes as if pulled by invisible tracks and shaded large swaths of ocean for hours at a time. Under the thin anvils, light became a uniform grey that made the world appear closer than it was. The moon watched from an orbit tighter than the one it would later prefer. Its face seemed large and personal. Its pull turned the ocean into a breathing machine with a pulse every few hours. In narrow seas, the tide did not simply rise. It charged inland as a travelling wall that climbed ledges and reversed rivers. In broad gulfs, the water sloshed with its own period, sometimes agreeing with the tide, sometimes arguing. The results carved shoals and opened channels, then buried them under newly transported sand and glass. A coastline was a verb here, not a noun. Every bay rehearsed a different version of the same music and rewrote its score with each cycle. Rock at the surface arrived young and hot. Ultramafic magmas poured like syrup and spread in thin, fast sheets that cooled to glossy skins before cracking into scales. Where eruption rates slowed and compositions shifted, basalt fields paved wide regions in hexagonal coves, each polygon a map of heat leaving stone. Viscous domes rose over deeper bodies that failed to break through, their flanks streaked by trickles that solidified into ribbons. When lava met seawater, the greeting was violent. Steam grenades shredded flows into fragments that rained into the shallows. Pillow masses stacked like beads and broke under their own weight into talus that tumbled with every set of waves. Through all of this, fractures opened and took in brine, then exhaled it as vapor laced with silica and metal. The exhalations plated the rock with delicate whiskers that survived a single tide or two before surrender. Ocean color carried arithmetic. Iron, in solution, stole blue and left an olive so dark it flirted with black. Suspended ash added a soot note that muted sparkle. The first meter of water ran busy with chemistry written by spray and light. The next 10 meters dropped to a somber green where shapes lost edges. Beyond that, visibility yielded to rules set by heat and density. Warm layers capped colder ones and resisted mixing until wind bullied them or tides kneaded them apart. Internal waves marched along the boundary between layers and rolled with a grace no eye could see from above. When these waves reached slopes, they broke silently and stirred deep water into new pathways, lifting nutrients and heat toward the surface and paying for the transaction with turbulence. Cloud microphysics had a different audience and kept its own schedule. Droplets formed around acids that drifted as seeds. They collided and coalesced under the tug of gravity, then evaporated when downdrafts dried the air, then formed again. Ice appeared aloft in thin plates that haloed the sun and moon with rings and arcs. In those upper reaches, latent heat released by condensation powered the next convective tower, a chain reaction that linked energy to structure one phase change at a time. Lightning, born in the quarrel between updraft and fallout, found channels through gases richer in carbon dioxide and poorer in oxygen. Each discharge cracked nitrogen and water into reactive pieces that met dissolved carbon at the sea surface and tried new arrangements faster than waves could wipe the slate. Impactors visited because the neighborhood remained untidy. Many skimmed the outer layers and drifted away as streaks that faded. Some refused modesty. A bead brightened against the haze and became a hard light that grew without restraint. Air compressed and heated ahead of its fall. Pressure raced along the surface in a circle that flattened waves and bent trees that did not exist. Water leapt outward, then fled back to fill a cavity that opened and steamed. Glass spheres fell into the cauldron and melted into it, or sank intact to become seeds for later crystals. For months, that basin hosted a weather pattern of its own. For years, it served as a thermal battery that fed vents along its rim. For centuries, the layer of spherules it threw down waited in silence for any future reader. Magnetism laced the sky after sunset. Auroral ovals slouched toward warmer latitudes because the star sent tantrums more often in its youth. Curtains rippled green with violet hems. Arcs formed and collapsed like slow heartbeats. Charged particles traced lines that sprang from a deep engine where iron moved against iron and created a field strong enough to deflect the worst insults. In their glow, the sea wore paths of light that broke into short dashes across the chop. The sound of surf turned polite for a moment when wind shifted offshore. Then the murmur returned to full volume, and the ocean resumed its argument with the stone. Heat transfer remained the main script. Radiation tugged energy out of the tops of clouds and sent it to the cold sink of space. Conduction whispered heat through rock to water that could carry it faster. Convection built and erased towers that released latent energy in bursts that dwarfed any single lava flow. Evaporation smuggled warmth upward. Condensation paid it back with interest. The entire planet functioned as a linked set of engines and exchangers that had one quiet task: keep water liquid despite a stingy star. The solution involved persistence rather than luck. Greenhouse gases welded a loose lid over the ocean. Clouds tuned the balance by reflecting some light and trapping much heat. Tides kneaded the seas and shores and spread the budget across the surface. Not every hour roared. After a squall, the world sometimes reached a careful pause. Low sunlight picked out textures on flows, turning cooling cracks into a lacework. Mist pooled in hollows and flowed like a thin river down slopes still warm from the previous night. In that calm, refraction made small miracles. A column of heated air above a flow bent light into mirages that floated distant islands and stacked them into impossible cliffs. Over water, temperature jumps folded the horizon into high ribbons, a fata morgana that built citadels out of cloud edges. The stage looked enchanted, though no enchantment was required beyond physics and patience. Chemistry found corners everywhere. In tide flats, a millimeter deep, salinity rose and fell as rills visited and retreated. Minerals that were invisible to the eye assembled into flock that drifted and then settled in thin lines. Clays exposed charged layers that coaxed molecules into alignment. Metal sulfides traded electrons with an enthusiasm that turned minor gradients into usable currents. Ultraviolet light pressed into these settings when the haze parted and left behind fragments that preferred not to stay broken. Winds rearranged the inventory, tides redistributed it. Nothing remained long where it began, yet small structures persisted for minutes and then for hours, which was long enough to matter. Sound tracked the mood of the engine. The heavy air gave thunder a velvet edge. Surf added a restless bassline. Vents whistled in keys set by the width of their throats. Far below, slow tremor waves slid along newborn ridges and under broad basins, a tempo so patient that any listener would have mistaken it for silence. Together, the noises marked the progress of energy from deep to surface to sky to space. There was no conductor, there was only agreement. As evening arrived, the sun turned coin-coloured behind high veils and sank with little ceremony. The moon raised the sea into mobile ridges, and draped a pale path across the dark water. Stars entered as fewer but larger points, smeared by ice rings and halos into companions that never were. A last storm lit its own skeleton with a single flash that revealed fluted updrafts and a crown that had punched into the stratosphere. The flash receded, the crown relaxed. Rain thinned to a bright dust in the final light. The planet kept working. Rotation moved shadows at a brisk pace. Tides negotiated with the coast and rarely lost. Heat climbed step by step, always looking for cold. Gases traded places without exhaustion. Water changed state often, and with consequence. Rock accepted, yielded, altered, and accepted again. The young world was not chaotic in the way of accidents. It was noisy in the way of industry, a precise shop floor with many benches and no idle tools. The ocean stayed liquid. The air held warmth. The sky made shelters and let them pass. A new morning waited only a short night away. He went looking for something ordinary, and found time hidden in sand. The hills were quiet, and the rocks looked unremarkable, a patchwork of banded greys in a dry corner of Western Australia. In the gravel of a pale streamed lay, pebbles made from older stones ground to crumbs. Within those crumbs slept crystals no larger than sugar grains, clear and pink and amber, each with a hardness that shrugged off the abuse of geologic storms. Zircon had survived burial, heat, grinding, and the weight of whole mountains. It kept its lattice intact and locked a diary inside. The diary opened to a date almost beyond narrative. Polished, set in resin, and peered at through microscopes that used ions rather than light. These tiny prisms gave ages in billions of years with the authority of their own decay. Uranium, tucked into the zircon lattices when the crystals grew, had been quietly converting itself to lead at a tempo no furnace could rush and no pressure could bruise. Count the ratios, trace the daughter to the parent. The arithmetic pointed to moments older than any known rock outcrop. Some grains carried a birth date around 4.4 billion years. They were fragments of a crust that no longer stood in place. Confetti carried forward by rivers that had long since vanished. The tools that read them had their own poetry. A beam of oxygen ions knocked atoms from the crystal surface and sent them into detectors that sorted masses by the swing of electric fields. Peaks on a screen rose and fell like a skyline. Each peak spoke a different isotope language. In one test, the focus narrowed to oxygen. The heavier isotope sat in excess, a signature that hinted the crystal had crystallized from melts that had seen low-temperature water at the surface. It was an implication with force. If the oxygen ratios recorded weathered crust, then liquid water had touched rocks early, and rain had danced on land well before anyone expected the climate to calm. Another thread followed hafnium. Zircon rarely forgets the hafnium it was born with. When magma grows zircon, the hafnium isotope mix carries the memory of the source. Reading that mix suggested that a portion of the crust had separated from the mantle in the planet's first few 100 million years. This did not require continents, as later maps would show them, but it implied buoyant granitic rafts or protocontinents that altered the cycle of heat loss and provided real estate for weather to act upon. Inclusions trapped inside the crystals strengthened the hint. Tiny bits of quartz, a whisper of muscovite, miniature worlds encased in harder glass, revealed temperatures and pressures more comfortable than a planet-wide hell should supply. Dismantling the crystals was an art. They were first sieved from crushed rock, then floated and sorted by density in heavy liquids that smelled like laboratories and rules. Under a microscope, a geologist picked the promising ones with a needle and pressed them into tiny wells of epoxy. A polish exposed cross-sections. Under cathodoluminescence, rings and patches lit up as if a tree trunk had switched on its growth bands for the camera. The rings held stories of growth, recrystallization, and trauma. Some showed dark rims where later heating had altered trace element inventories. Others showed bright cores that looked pristine and ancient, circled by younger halos like small planets wrapped in later atmospheres. The first announcements drew both excitement and caution. Could lead have wandered in the lattice and fouled the clocks? Could radiation damage and later fluids have written new ages across old faces? Experiments bombarded modern zircons with heat and pressure to see what would shift. Atom probe tomography sliced the lattice into chains of ions and counted them one by one, revealing clusters of lead atoms like constellations trapped in crystal space. The clusters behaved in ways that reassured the ages rather than undermined them. Where the grains showed fractures, ages slid younger near those cracks. Where the lattice remained whole, the clocks kept time like saints. The crystals did not speak alone. Other terrains joined the conversation. Ancient rocks in Canada offered gneisses a little over 4 billion years old. A greenstone belt in a far northern bay argued for igneous events even earlier. These were not continuous continents from the earliest time, but they were stubborn survivors. Together with the zircon records, they suggested a planet where the first crust formed quickly and was recycled aggressively. The easy pieces had been lost. The zircon grains were the true archivists, stashed in younger sediments, carried into new basins, and exhumed by erosion and curiosity. Oxygen isotopes did more than whisper about water. They hinted at temperatures. The fractionation between heavy and light oxygen in minerals depends on heat. The compositions in the oldest grains lined up best with melts derived from crust, altered in the presence of cool water rather than scalding brines. Titanium offered another thermometer. Its trace abundance in zircon changes with crystallization temperature. When measured with care, the numbers came back cooler than a planet-sized volcano would suggest. Not cold in any human sense, just not a relentless inferno. A narrative began to form in which oceans condensed, at least in places, and remained for long enough to cycle rocks through weathering and burial. Hafnium told a complementary story about timing. The isotope that matters most is created by the decay of lutetium, and the balance between them changes as time and geologic processes do their work. In the earliest grains, the numbers indicated that parts of the crust had split from the mantle by about 4.3 to 4.4 billion years. That separation placed buoyant material at the surface and set the stage for repeated melting, differentiation, and recycling. Rather than a single hot lid, the planet may have experimented with local overturns, drips of dense roots peeling away, and strips of new felsic crust rising to replace them. The zircons acted as spies from those experiments, tiny reports sealed in hard envelopes. The instruments that retrieved these reports were themselves part of the story. Secondary ion mass spectrometers weighed atoms flicked from crystal surfaces by beams with a delicacy that bordered on audacity. Laser ablation split trace elements into clouds mere micrometers across. Thermal ionization rigs counted ions with patience, turning long nights into age spectra that pleased and infuriated in equal measure. Each lab taught the crystals to speak in a slightly different accent. The conversation enlarged as methods cross-checked one another, and as more grains were pulled from more sediments in more basins. The places that yielded the richest caches were not dramatic mountains but humble metasediments, transformed by deep time into tough rocks called quartzites and schists. They began as sand and silt. Rivers carried them from uplands that no longer stand. In those first basins, currents sorted minerals by size and density. Zircon, hard and resistant, rode the mid-depths of the flow like a seasoned traveler, then settled in swirl zones where water slowed. Bury the deposits, warm them, squeeze them, expose them again. The grains survived. They outlived the landscapes that made them, and the maps that would later ignore those lost places. Occasional inclusions told of pressure and fluid. A trapped bubble of carbon dioxide hinted that water and gas circulated through rocks at moderate depths. A fleck of apatite recorded phosphorus available for incorporation into minerals common in evolved crusts. A tiny needle of rutile carried titanium that doubled as a thermometer. All of it sketched a planet that had already learned the subtle arts of sedimentation, low-temperature alteration, and partial melting. The lesson ran against the intuition that a young world should be uniformly violent. Violence was present, but so was the quieter labor that reshapes rock by weather rather than by fire alone. Skeptics never ran out of good questions. Could oxygen have exchanged in the lattice after the fact? Could metamorphism blur the fractionation signatures? Could the heavy isotope have been introduced by hydrothermal fluids, unrelated to weathered crust? Researchers answered by mapping isotopes, ring by ring within single grains, by correlating textures with values, and by finding consistent stories across crystals from different locations. Zones that looked repaired or recrystallized carried different numbers. Pristine cores lined up with each other, even when outer rims disagreed. The coherence leaned toward original signals, imperfectly preserved, but legible. One of the most arresting images was not visual at all, but a graph that plotted ages against hafnium ratios. The points fell along trends that required early differentiation and persistent reworking. The slopes looked like a slope of memory, an angle at which the planet's capacity to build and rebuild crust overran any model that insisted on a long, stagnant lid. The strength of these lines lay not in a single spectacular grain, but in the sober accumulation of many modest grains, each one a footnote to a chapter that had mostly burned away. There were other witnesses. A perfume of xenon in the atmosphere, altered by ancient escape to space, added a whisper about early loss and later retention. The oldest sedimentary textures in far-flung places debated whether sunlight had glinted off water or not. Yet for direct testimony, nothing matched the zircons. Their size belied their reach. They spanned time like bridges fabricated from atom-scale beams. They refused to lie about their ages, and when coaxed with respectful methods, they volunteered clues about temperature, water, crust, and the pace at which the planet learned complexity. A scientist set a freshly polished mount under the ion beam, watched the numbers accumulate, and felt the quiet click of understanding. Inside a grain smaller than a punctuation mark lay an age that pushed oceans and weather into the planet's earliest chapters. Inside another, a hafnium signature required a crust light enough to float and stable enough to be reworked. The mountains that gave birth to those sands were gone. The zircons remained. A memory palace built from silica and oxygen, decorated with trace elements that behaved like annotations. No grand monument survives from those years. Only these crystals, picked from sand and taught to speak, tell how early Earth looked not as a painting but as a set of conditions. Warm enough, wet enough, busy enough, ready. The sky read as an equation more than a color. Gases wrote the terms, and sunlight solved them every hour. Nitrogen did the quiet work of volume. Carbon dioxide shouldered radiative burden. Water vapor hung in movable archives that stored heat and released it with interest. Trace players shifted the palette. Sulfur dioxide climbed from volcanoes and oxidized into sulfates that brightened cloud decks. Methane pooled in low layers where chemistry permitted and turned to hazes when sunlight clipped its bonds. Hydrogen drifted upward and escaped, a slow leak that changed everything by changing nothing at any single moment. The light itself arrived with a spectrum that favored red once it entered the lower air. Short wavelengths scattered from molecules with a delicate efficiency that would normally paint blue. Aerosols interfered. Tiny particles bent brilliance into a luminous smog that pushed the sky toward copper at low angles and toward pewter higher up. The human eye would have hunted for blue and found it muted under a sheet of grey gold. In thin spots, the color returned, not as a cheerful field, but as a pale dome, washed by high ice and acid droplets that smeared the sun into a disk with velvet edges. Scattering followed rules set by size. Molecules scattered in proportion to the inverse fourth power of wavelength, a law that should have ruled the day. Particles larger than light's short waves scattered without favor and turned clarity into glare. The balance between the two slid with every eruption and with every patch of haze baked from methane. Morning could begin with a bronze wash, and noon with an aluminum sheen. Evening could pass through bottle green before conceding to orange. The same physics drew rings around the moon and threw false suns into the halo that bright crystals built without intention. Without abundant oxygen, the air lacked a proper shield against ultraviolet. There was no thick ozone column to intercept harsh photons. UV carved through the column and forced a different ecology of light. Water surfaces sparked with chemistry. Minerals bleached into new valences. For a time each day, the top film of every pool became a reactor set to a fierce wavelength. Clouds controlled the hazard by gathering water into towers and spreading anvils that shaded wide districts. When those anvils thinned, sunlight reasserted its control and wrote equations into brines and films in writing too small for eyes that did not yet exist. Pressure set the stage for sound and weather alike. Dense air slowed the fall of rain and softened thunder into rounded bodies of noise that rolled rather than cracked. The lapse rate, that quiet slope of temperature against height, varied with humidity and dictated the reach of clouds. When moist air rose, it cooled along a gentle curve as condensing droplets surrendered latent heat. Updrafts climbed higher before equilibrium caught them. At the top of the column, radiation tugged at the cloud until the balance returned. The cycle ran like a pump. Heat entered as evaporation from broad seas, moved upward as invisible cargo, and departed from tall, cold heights as infrared pourings into space. A planet with a smaller solar allowance chose greenhouse strategies that worked. Carbon dioxide absorbed in infrared bands that intercepted the ocean's attempt to cool the surface. Water vapor overlapped in places and extended the blanket. Methane added teeth at longer wavelengths and sharpened the edge of the trap. Hydrogen, when present enough to matter, broadened absorption features by colliding with its partners and smudging lines that would otherwise have been narrow. Clouds complicated the budget. Low decks reflected sunlight back to space and cooled the ground. High, thin veils trapped outgoing heat and warmed it. The daily solution varied with the mix. The long-term result preserved liquid oceans under a star that was still learning generosity. Each molecule left an optical fingerprint. Carbon dioxide etched dark notches into the outgoing spectrum near 15 micrometers. Water vapor wrote a forest of lines across wide bands. Methane bit near 3 and 8 micrometers. Sulfuric aerosols scattered forward with a preference that made halos and cast hazy shadows. Even nitrogen, largely indifferent to light, joined the conversation by broadening the signals of more active gases through collisions that altered how energy moved between rotational and vibrational states. A spectrometer held to the sky would have seen the policy of the air rendered as missing pieces and softened shoulders. Electricity found paths where ice and droplets met in violent negotiation. Updrafts lofted supercooled water into layers where tiny ice crystals grew by stealing vapor from their warmer neighbors. Collisions separated charge. The top of the cloud carried a different sign than the base. A field grew and then insisted on discharge. Channels reached toward the surface and toward space in pulses too fast to follow by eye. Without trees to catch flame, the bolts found brine and rock. Their chemistry mattered more than their fire. Nitrogen split. Oxygen, scarce though present in constrained forms, joined reactions like a guest allowed to speak only when spoken to. New compounds formed and dissolved into rain that returned altered signatures to film and flow. At night, the upper atmosphere glowed quietly, even when aurora slept. Sodium left by meteors formed a layer that fluoresced in amber under starlight and temperature disturbances. Oxygen atoms rested near 90 kilometers and released green photons when allowed to recombine. Hydroxyl emitted a faint red along bands that mapped waves moving upward from storms below. Airglow painted a soft canvas that haze thickened into smooth color. The world did not become dark so much as it shifted registers into muted luminosity. Solar wind struck with more vigor than it would show later. The magnetic field intercepted and guided it along arcs that curved toward poles. In those high regions, charged particles slid into thinner air and excited atoms into color. On some nights, the curtains sagged toward mid-latitudes and unfurled across the sea. The green line dominated, with violet hems stitched along the lower edges where collisions were more violent. The display changed the mood more than the temperature, yet it marked the shield doing its work, sparing the lower air from ionization that would have rearranged chemistry with reckless haste. Climate walked a line between reflectivity and retention. If hazes grew too thick, they cooled the ground by bouncing sunlight back to space. If gases concentrated beyond that, they trapped so much heat that clouds grew higher and storms stronger. The system did not aim for balance. It arrived there by failing to do otherwise. Carbonate precipitation took carbon from the air and locked it in stone when oceans grew warm and alkaline enough to allow it. Volcanic outgassing returned carbon when plates recycled. Weathering of basalt consumed carbon dioxide by turning rock into clays and bicarbonate in solution. Each lever pulled with a speed set by temperature, relief, and rainfall. The feedbacks did not hum on human time. They spoke in tens of thousands of years and more. Optics told weather in small. Halos around the sun implied high ice and a stable layer aloft. A parhelion hinted at crystal plate orientations and winds nobody could feel. Coronas around the moon betrayed droplet sizes in lower decks. The color of shadows at noon reported aerosol thickness. Reddening at sunrise mapped the length of path through haze. Iridescence along cloud edges marked wave motions and droplet uniformity. The sky displayed its instruments openly and needed only practice to read them. A traveler with sensitive skin would have learned the day in layers. Morning haze felt like powdered glass in the throat. Midday UV drew an invisible edge across the top of every pool and led to a shimmer that was heat and photochemistry both. Afternoon anvils brought relief, their shade a moving architecture that calmed water without quieting it. Evening winds carried scents of sulfates, brine, and wet rock as downdrafts spread beneath dying storms. Night breathed cooler, but not cold, the dense air holding warmth near the surface and letting it leak only as rapidly as radiation through a milky lid. The ocean returned the sky's gifts with slow diplomacy. It took heat at the surface and carried it into the interior along overturning paths set by salinity and temperature. It exhaled moisture into winds that carried it to places where mountains and convergences insisted it fall out again. It absorbed carbon dioxide and released it when pressure and temperature changed the bargain. It condensed the history of the sky into layers of temperature and chemistry. The surface ruffled explained recent hours. The thermocline held weeks. The abyss remembered years. There were no colors reserved for life. Yet the air produced a theater full of cues more complex than a clear noon and a blue dome. It was a sky with weight, a sky that bent light by particulate rules, a sky that managed heat by deploying gases and clouds in shifting proportions. It looked alien yet worked with familiar mathematics. It trapped enough warmth to keep the ocean liquid. It allowed enough reflection to avoid a runaway. It punished surfaces with ultraviolet while offering windows for infrared to leave. It arranged electricity into lines and curtains. It carried the flavor of a young world, determined by physics rather than preference. As the short day closed, the last light turned edges of haze to brass and left the upper air glowing faintly. The horizon lifted a thin green flash where refraction and color met for a breath. Then the line went dark, except for the slow twining of auroral silk. The atmosphere continued its sums at night. Reactions paused and resumed. Droplets formed and evaporated. Heat crawled outward. The sky never slept. It adjusted. The ocean wore the role of furnace and memory at once. A modest star delivered less power than it would in later ages, so the sea learned to keep every delivered calorie with thrift sharpened by necessity. Heat arrived as shortwave bands where haze allowed it, slipped through the top meter, and met water with a capacity generous enough to dilute extremes. The surface warmed, then paid its debt upward by evaporation and downward by conduction, only slowly. The transaction measured in hours for air and in seasons for depth. A thin skin, a few millimeters thick, ruled the exchange. A fragile boundary that decided how much of the day's light would lie down to sleep in the deeper bed. Winds teased that skin into cat's paws and capillary ripples. Each tiny crest increased the chance for sunlight to enter rather than glance away. Spray leapt from breaking crests and returned as a snow of salt that thickened air at the interface and modified cloudbirth above. The feedback ran quiet. More spray seeded more droplets. More droplets yielded more shade. More shade trimmed the heat budget but also trapped infrared trying to leave. A negotiation carried in the shapes and altitudes of clouds. When decks sat low and thick, they reflected well and cooled. When veils stretched high, they warmed the sea by catching its sighs and returning them. Beneath the surface, temperature wrote layers. Warm, lighter water, capped cold, denser water in a profile that steepened until wind or tide bullied it into mixing. Internal waves strolled along the meeting plane like ghostly tsunamis, hundreds of meters high yet invisible to eyes that could not dive. Where those waves spilled on rising slopes, turbulence kneaded the boundary and pushed nutrients and heat across it. The result was a circulation more nuanced than a single ribbon looping pole to pole. It was a braided conveyor, driven by salinity, temperature, and the push of tides through straits and over ridges newly minted by a feverish interior. Salinity carried its own logic. Rivers that existed where land rose supplied a dilute contribution streaked with metals. Hydrothermal vents balanced the equation by injecting warm, mineral-rich water along seams in the crust. Evaporation under clearings salted surface layers. Rain under anvils freshened them. The pattern varied from basin to basin, a mosaic of brine signatures that wrote faint fingerprints across the thermocline. In narrow passages between volcanic islands, tides accelerated until water climbed in standing walls, then reached back with fingers of undertow that scraped the bottom and raised cool plumes. In broad embayments, the tide set the entire sea in a slow slosh that took hours to turn, a motion large enough to rule the fate of heat for kilometers around. Light did not penetrate far. Iron and haze residues swallowed blue and left a greenish dusk that yielded to grey within a short descent. Life's palette had not yet painted the water with chlorophyll's familiar absorption, so the spectrum fell out differently than a later era would show. Lacking extensive phototrophs, the sea preserved clarity only in patches scoured by currents, and even there the sense was of a world more dim than bright. Yet dimness helped the budget. Less surface light meant less glare lost to space. What entered tended to stay, shepherded into storage by the sea's reluctance to change temperature quickly. The star's youth brought moods to its wind that had consequences at the surface. Outbursts loaded the upper air with energy and refined the chemistry that set cloud nucleation. After such events, high hazes grew or thinned depending on the composition they inherited. The ocean's response came hours to days later. A slight shift in sunlight altered evaporation. A small change in evaporation altered cloud base heights and the spacing of convection. Storms that fed on sea surface temperatures found their fuel trimmed or padded at the margins. The sea did not control the sky, but it tuned it and took tuning back in a loop that barely noticed continents when they were present at all. At high latitudes, the debate between ice and open water played out on lines that wandered with season and with storms. Where ice formed, it brightened the planet and flashed sunlight back to space. Where it opened a lead, dark water drank light and grew warmer by a few precious tenths of a degree that mattered. The margin fractured easily under tides that tugged more strongly than they would in later eons, turning the edge into a lace of flows that came and went with weather. Brine rejected from newborn ice sank and helped drive overturning cells that carried surface chill downward while importing warmth from below to arrest the advance. It was not a static shield, but a mobile architecture managed by winds, tides, and density. Sound traveled with uncommon reach. Dense water and stable layers created channels that bent acoustic energy back toward the deep, so a single fracture at the surface could carry its note for long distances underwater. Hydrothermal fields hissed at pitches too low for an animal that did not yet exist. Breaking waves wrote static across the spectrum. Internal waves thumped like slow drums when they collapsed. The ocean's acoustics formed an archive no ear could hear, but that a later instrument would decipher into maps of temperature, current, and mixing. Chemistry drew diagrams that had nothing to do with noise. Carbon dioxide dissolved into the sea, reacted with water, and split itself among dissolved carbon species whose ratios depended sensitively on alkalinity and temperature. With iron abundant and oxygen scarce, the redox state favored reduced forms. Carbonate minerals precipitated in some basins and refused in others, choosing terraces around vents and quiet shelves downstream of islands where chemistry pooled. Silica delivered by vents and weathering convinced water to grow opal thin skins on grains and to bead along walls where gradients were strong. Sulfur shuffled through vent circuits, sketched subtle halos in layers measured in centimeters, invisible to the eye but legible in the stubborn logic of ions. Waves wrote geometry across open reaches. Swell trains born from distant storms organized into bead strings that wrapped around island chains and focused energy into predictable hotspots along coasts. In those hotspots, cliffs rang and collapsed. The rubble became platforms where chemistry had time to concentrate before the next tide reclaimed it. Rogue waves did not require myth. Interference between crossing swells and currents over submerged sills built heights that doubled the background sea in an instant, then faded as quickly. Every event rearranged rock and delivered new surfaces, an unending supply of fresh canvas for films and salts. Below the ridges where the planet parted its crust, vents lined up like city lights seen from a high pass. Their plumes rose until they found density matches, then spread in thin layers that stacked like pages in a book. Those pages carried heat laterally for tens of kilometers before mixing blurred their edges. Along each layer's inner margin, metals dropped out as temperatures fell, sketching pale streaks and dark veils that draped the seafloor in mineral cloth. Even away from the axis, warm seeps and diffuse flows offered softer gradients that lasted longer, a patience different from the violence of focused chimneys. Pores in these neighborhoods measured distances in hairs and voltages in millivolts, numbers small enough to escape spectacle, yet large enough to drive steady work. The faint sun puzzle lived in such details. Keep reflectivity modest, keep long-wave escape inhibited, move heat from places of surplus to places of need without losing too much to space on the way. The ocean succeeded by being large, by changing slowly, and by negotiating with sky and stone in feedbacks that leaned towards stability. Weathering of young basalts consumed carbon dioxide more rapidly when the sea was warm and wet, threatening to cool the world, but spreading ridges and hyperactive volcanism returned carbon with insistence. When hazes thickened and cooled the surface by bouncing light upward, the sea answered by shedding fewer clouds and by exposing darker water under gaps, hemming the chill. The levers were not calibrated by intention, they were balanced by consequence. Tides contributed a mechanical subsidy. With a nearby moon, the daily kneading of shores and sills pumped energy into mixing at levels that later ages would lack. That mixing broke the resistance of stratification and let warmth from shallows reach into cold basins while stirring cool into places where heat had begun to accumulate. It worked even in darkness, even in winter, even when the wind fell flat. The tide tables wrote a poem of forced circulation that the planet recited every day without fail. On calm mornings after active nights, the upper ocean sometimes lay like hammered metal. Narrow lanes of slick water alternated with rough strips aligned with the breeze. In the slicks, organic films corralled by Langmuir cells concentrated in gleaming arcs. Between them, roughness betrayed upward jets that dragged cool water toward the surface. A hand extended from a boat that did not exist would have felt one band warmer than the next by a fraction of a degree, yet the difference mattered at the scale of cloudburst a kilometer above. The ocean leveraged small contrasts into altered skies and received altered skies back as heat relief or burden. The story belonged to scale. Square kilometers of cloud field shifted the fate of petajoules. Square meters of film decided whether microlayers thickened or tore. Kilometers of ridge set the tone for whole basins. Micrometers of pore mouths set the budget for chemical cells. Through all of it, the sea kept its promise. It held liquid against a parsimonious star by turning mass and specific heat into policy, by coordinating with gases that trapped warmth, and by accepting help from tides that never forgot to return. Evening spread a low, bright band across the west and left the surface reading like oxidized bronze. Heat that had slipped into the first dozen meters during daylight began a patient migration downward through nighttime convection as the skin cooled. Fog formed where warm water met cooling air and threw its own blanket back over the exchange. A swell from a storm beyond the horizon arrived and imposed an order on the chop, long-period lines that shouldered aside local waves. Under the new rhythm, the ocean exhaled less and saved more. It was not a conscious act. It was competence expressed as physics. Fire worked in cycles that could be measured by scars. Deep plumes rose like slow thunderheads inside rock and pushed the surface upward long before any eruption began. The first sign was a swelling, a broad dome that warmed without a visible source. Then fissures opened in parallel files and exhaled a heat so clean it moved air by itself. Lava poured in sheets rather than fountains, thin and quick, rivers of ultramafic melt that glowed dull yellow by day and white by night. These floods ignored channels. They built their own. They ate paths into the sea and laid pavements that ran for tens of kilometers, before cooling into satin black. The planet vented pressure, and in venting it, rebuilt coasts, folded new sills into old basins, and reset the rules of water and air. Ash did not travel alone. Volcanic columns lofted shards of glass, crystals, and gases into a stratified sky and wrote transient climates. Sulfur dioxide oxidized in place and matured into a veil of aerosols that brightened cloud decks and sharpened sunsets. The veil shifted the balance between reflection and retention. Day turned paler, and night stayed warm under a lid that scattered infrared sideways like fog around a lamp. Chlorine and fluorine rode the same winds and fell out as acidic rains that etched basalt into clays within days. Each storm translated fire into weather and weather into chemistry, setting timelines that ran from minutes to years. Where lava met seawater, violence hid in steam. Shorelines turned to factories for broken glass. Waves attacked, flows still soft enough to deform and shattered their skins. Hyaloclastite ground underfoot like black snow when the sea withdrew. Once the froth settled, the fragments served as high surface area substrates for films and salts. Heat left those beaches by coughing in bursts through vents small enough to miss the eye. Around each throat, delicate whiskers of silica and iron grew overnight. The next tide tore them down and scattered their dust into pools that already hovered at the edge between saturation and precipitation. The coast became a workshop lit by stray lightning that found the tallest plumes and grounded itself into brine. The larger visitors arrived from above and edited the script without courtesy. An object wide enough to own its own gravity fell through haze and gave notice in brilliant silence. Air compressed and screamed as pressure waves ran out from the path. Stones permanent enough to have names in another epoch would have lifted and floated like toys on the passing ring of flattened sea. The strike heated water into steam so quickly that the phase change behaved like a weapon, foam flung outward. Shock fractured bedrock and flashed pockets of trapped gas into jets that carved their own channels in the chaos. When the blast ended, a basin breathed and steamed and glowed with heat stolen from motion. In the weeks that followed, the atmosphere bent to the new regime. Steam injected at once, condensed into cloud that circled the world and fed rains far beyond the crater's temporary shore. Dust and droplets altered the quality of light, turning noon to a pewter that admitted less heat but reflected warmth downward at night. Glass spherules fell into fields and seas, still soft enough to distort upon landing, then hardened into a layer that would lie quiet under sediments until a future hand turned it over. Metallic fragments reacted with water and shed phosphorus into solution as they weathered, a rare, reactive form that drifted into lakes and shallow bays, where concentration meant advantage. The ocean tasted different for a season, richer in nickel and cobalt, and the side effects of iron's stubborn solubility in an air bereft of free oxygen. As the warmth subsided, the crater kept working. Vents ringed the broken rim and exhaled fluids that had met rock at temperatures too high for comfort, but not hot enough to kill subtlety. The water within the bowl stratified into layers by density. Hot brine sank while fresher rainwater pooled above. Fingers of mixing traced lace along the interface and drew pale lightning of precipitated minerals into floating drifts. Around the edges, terraces stepped downward from seeps, each rim a snapshot of chemistry at a particular temperature and pH. Metals first fouled solution, then cleansed themselves in successive bands. The architecture read like a paused song, restart the flow, and the next terrace would resemble the last with a variation or two. Even without the insult of impacts, the interior could flood half a continent with magma. A plume head widened under the lid and cracked the crust along arcs. Fissure eruptions opened like zippers and ran for months, sometimes years, pouring out sheets that buried weather and rivers and old coastlines together under a new, warm floor. Air chemistry stumbled under the load. Carbon dioxide surged. Water vapor joined it. Sulfur aerosols lifted a bright canopy. The composite effect resisted simple description. Days cooled slightly, nights failed to. Rains became more acidic, which increased weathering, which stole carbon dioxide from the air and moderated the greenhouse rise. Fire pulled a lever, stone pulled a lever back. Tides took advantage of the new geography. Fresh sills and steps focused currents into jets that raced through gaps and hammered bottoms bare. Mixing events, once regional, now carried into the open ocean as the jets lost energy and shed eddies. Where eddies spun down, they gathered floating rafts of pumice and mats of foam into spirals that tightened until they touched stone. The spirals marked places where thin films could persist longer than elsewhere, fed by repeating waves that did not quite wash the slate clean. Chemistry rarely thrives on perfection. It prefers near misses and second chances. The sea offered both. The young star above did not withhold storms. Bursts of charged particles slid down magnetic corridors and excited air until it glowed. In the wake of those displays, ionization at altitude altered the pathways for charges in lower storms. Lightning over ash plumes found its routes adjusted and grew denser near the edges where updraft and fallout quarreled. A single night over a fissure could count more strikes than a quiet month elsewhere. Each discharge imprinted a geography of voltage on the water, driving brief electrophoretic drifts of charged molecules across films and into pockets where they could not have met without help. The physics of weather doubled as a courier for subtle freight. Dark seas deepened after the largest events. Iron remained in solution under an anoxic atmosphere and lent the water a heaviness of color that swallowed color from above. Ultraviolet worked at the surface, yet could not master the column. Heat pockets formed around volcanically heated seamounts and pushed thin troposcales into the water, regions where tiny temperature shifts convected in minutes rather than hours. Microcurrents traced figure eights around rocky spires and left narrow bands of clarity downwind where particles settled in the lee. There the light reached slightly farther and illuminated lattices of silica and iron that had precipitated out in the slow choreography of cooling plumes. Storm belts swam around the tropics like living things and dragged lines of convergence across the same corridors month after month until a new eruption, a new basin, a new temperature gradient nudged them aside. When they stalled, they dropped rain with persistence rather than fury. The deluge carved gullies in fresh lava and built fans that advanced into shallow seas where every grain could be read as a record of weight carried for a distance. In those fans, channels scrolled across their own benches between showers and left stranded bars that baked in brief sunlight, then dissolved again under the next high tide. The sediment itself was a signaling medium, a moving registry of supply, energy, and chemistry. Fire had a separate discipline at depth. Dikes that failed to reach the air found their breakthrough along the seafloor and extruded glass that fractured into ropey skins. Pillow piles slumped and refilled in slow landslides that shuddered across flanks like the breaths of a sleeping animal. Gas exsolved as pressure dropped, forming vesicles that later filled with secondary minerals. The voids trapped miniature histories of fluid composition. Open a vesicle, and it looked like an eye rimmed in crystalline lashes. Closed again by a later vein, it held an aquarium of clues that would only be read when stone returned to light. The balance between haze and clarity never found rest. Methane built localized shields that drifted like burnt sugar clouds and cut ultraviolet to a safer dosage in their shadows, while lowering the heat budget by day. Carbon dioxide kept the common hearth warm enough to keep ice in check. Ash swung the mirror back and forth. Aerosols brightened and cooled. Their lifetimes lasted weeks to months, long enough to season a year, too short to change a century by themselves. None of these actors worked alone. The script emerged from their quarrels and alliances, and the direction came from mass, rotation, and time rather than intention. A day after an eruption ended, a coast smelled like coins and wet pottery. Water ran off young glass and carried invisible metals that colored no stream yet altered its hands. Vents hit crescendo by night when air cooled and allowed plumes to stand like candles, then calmed by afternoon as pressure fields shifted. In the open ocean, a thunderhead pulled its anvil across a broad patch and built a temporary night at noon, then moved on and left the surface to warm brighter than neighboring water by late day. That warm patch seeded the next column. Heat birthed its own pathways and traveled them until a new piece of geography demanded a reroute. What the fires and falls accomplished together was not purity, but variety. Uniform planets struggle to invent. This one did not. It made cliffs and talus, domes and trenches, deltas and armored benches, vents and lukewarm seeps, hard shadows and hazed light. It salted water, freshened it, charged it, calmed it. It lifted metals from stone and taught them to travel. It brewed phosphorus from meteoritic alloys and persuaded it into solution. It supplied steady heat at depth and irregular jolts at the surface. It offered gradients in temperature, acidity, redox, and voltage, woven so densely that failure in one niche meant opportunity in the one beside it. Night fell on a coast, still hot to the touch in the cracks. Stars smouldered behind bright rings, a dome of ash thinned into streaks that would be gone by morning. The sea ticked against the new edge it had been given and tested every weakness. Far offshore, a plume along a ridge continued to breathe without drama. A few glass beads, latecomers from a broken sky, tapped the surface and sank, each one a record of speed cooled to stillness. The planet exhaled, not in relief but in rhythm, ready to ignite another page and to let the ocean rewrite it line by line. Islands began as ideas in hot stone. The planet's skin thickened where melts cooled below the sea and rose where buoyancy found a foothold. The earliest rafts were thin and dark, made of basalt laid in sheets that flexed like tempered glass. Beneath them, the mantle ran warmer than any later age would tolerate, so partial melting worked fast and often. Where melt lingered and crystallized slowly, dense roots formed. Where melt separated into lighter fractions, new compositions climbed toward the surface like lanterns rising in a night of rock. The chemistry of those lanterns mattered. Fluids shaved from the base of the crust carried sodium and silica into melts that were lighter than the basalt above them. These melts gathered in pockets, joined, and rose in diapirs that pushed surrounding rock aside. The result was a pale stone that did not yet answer to granite but moved in that direction. Tonalite, trongemite, and granodiorite filled domes with a quiet glow when freshly broken, a feldspar brightness that told of water lowering melting points and of repeated separation between heavy and light. Such domes stiffened the surface and taught pieces of the planet's lid to float higher. An island did not need height to matter, it needed persistence. Between domes stretched belts of darker rock altered by heat and pressure. Basalts metamorphosed into amphibolites where water threaded through and raised the grade. In zones that sank deeper, the same basalts transformed into eclogites dense enough to pull downward if given a path. Density contrasts wrote their own mechanics. Where heavy packages formed, they peeled away and sank like anchors dropped from a moving ship, a process quiet at the surface and profound at depth. Their departure let the lighter portions rise further. The landscape sorted itself by mass and temperature, and the sorting produced relief that rose slowly yet constantly. Subduction worked where heat ran high and crust ran soft. Rather than plates driving headlong, weaker belts sagged between stronger blocks and flowed downward like a heavy cloth draping over ribs. The sinking strips heated, dehydrated, and fed fluids upward into the hanging bodies. Melts followed the fluids and collected in lobes that swelled beneath the domes. The surface read as a quilt of pale highs and dark lows, patched by belts of schist that once were lavas and ash. Greenstone belts formed valleys between igneous keels and carried memories of pillow lavas, turbidite fans, and chemical sediments laid in basins that opened and closed on short geologic schedules. Where the ocean's floor thickened over mantle plumes, broad volcanic plateaus lifted into the light and served as seedbeds. Their mass helped them survive the ordinary recycling of basaltic crust. Over time, water that infiltrated along fractures altered their interiors, turning hard minerals to clays, releasing sodium and calcium into solutions that would nourish later melts. When heat returned, the altered plateaus melted at lower temperatures and sent lighter magmas upward. The process did not require deep subduction trenches. It required gradients and time, and the repeated visit of hot material from below. Margins of the rising rafts leaked. Dikes cut outward in radiating swarms, thin sheets of melt that froze into ribs. Sills intruded along bedding planes and puffed layers apart, a geological pastry with dark fillings. In the shallow crust, chambers inflated and failed, exhaling shallow ignimbrites that settled as welded sheets and hardened into pink and grey rock, with flattened shards shining in cross-section. The islands grew in breadth, even when they did not grow in height. their outlines scalloped by embayments where tides gnawed at loose faces and rearranged fresh debris into beaches of angular glass and feldspar sand. The weight of domes bent the lithosphere. Basins subsided around rising blocks and filled with sediment stripped from their flanks. Rivers short and impatient braided across low gradients and led into bays where tides reversed their flow twice a day. In those basins, mud settled in millimeter layers that marked storms and lulls like the lines in a diary. Ash fell from distant volcanoes and left pale pages in the book. Hydrothermal plumes wandered in from offshore vents and contributed iron that stained the record with thin, dark horizons. When domes swelled again, the basins lifted part way and folded. The diary wrinkled and kept going. The heat engine tempered as islands multiplied. Surfaces that once bled heat like open wounds now returned it more slowly. Weathering bit deeper and faster into pale domes than into glassy basalt, and the products of that weathering changed river chemistry. Sodium and potassium travelled inland to sea. Silica rode in solution and reappeared as cements that glued early sands into hard rocks. Carbon dioxide vanished from air into bicarbonate in streams and into carbonates where basins allowed. The atmosphere noticed, just enough to matter. Clouds grew or thinned with the adjusted budget. Rains favoured slopes with new relief. Erosion sharpened ridges and made talus aprons that carved into the sea under higher tides. Under these islands, the mantle wedge grew wet wherever downward drips of dense crust released fluids. Water lowered melting points and multiplied melt volumes. Basaltic magmas that rose through the wet wedge arrived with signatures distinct from dry sources. Their trace element patterns hinted at recycling already in progress. Arcs of small volcanoes aligned along the edges of rising blocks, a geometry that suggested subduction without the long, rigid slabs that would dominate later. The arcs leaked gases that added to the sky's mix and, at intervals, sprayed ash into the basins that circled the domes. Komatiite still flowed in some provinces, hot and thin as liquid metal. It threaded between growing felsic bodies and paved their toes with iron and magnesium-rich sheets that shimmered when cut. Those flows captured the last notes of a hotter mantle and, when metamorphosed, left spinifex textures that preserved the direction of cooling in bladed crystals. Beside them, cooler basaltic flows stepped down from low shields and met water in quiet hisses. The juxtaposition of extreme and moderate recorded a mantle in transition, cooling unevenly, melting in pockets, feeding the crust with a varied menu rather than a single dish. Every island hosted a laboratory of shallow processes. Weather etched feldspar into clays that swelled when wet and cracked when dry, increasing porosity and inviting more water. Oxide skins grew along fractures where transient oxygen stole electrons during rare photochemical events in pools. Pyrite crystallized in anoxic sediments and later oxidized in brief exposure to air, staining outcrops with ochre and leaving acidity that gnawed at nearby rock. Salts climbed out of brines by capillarity and crusted sunlit surfaces, then dissolved again at the next tide, a cycle that weakened faces and fed ions back into circulation. Tectonics explored options in these provinces. Blocks rotated as low-angle faults sliced beneath them. Detachments slid, allowing upper crust to expand and thin while deeper parts rose. Domes stretched and split along axes, admitting fresh magma that re-stiffened the system. Some pieces broke away as microcontinents and drifted along slow currents in the warm lid, their keels thick enough to resist foundering. When they collided, pressure folded their margins and metamorphosed basalts into banded amphibolites that wrapped the cores like scarves. The collisions were gentle by later standards, yet sufficient to stitch islands into archipelagos with shared basins between. Sea level danced to more than tides. Thermal expansion swelled the ocean where heat pooled under stagnant winds and fell where cool water upwelled along new coasts. When volcanic plateaus rose, they displaced water outward and flooded neighboring shelves. When basins subsided around domes, they accepted that water and built quiet jars for sediment. Shorelines stepped across their own shadows in terraces that kept count of these shifts. Inlets captured rafts of pumice and mats of floating foam, then beached them to dry and crumble into feedstock for the next storm's chemistry. The mineral record inside the island stored temperature and pressure like a set of gauges. Garnet cores held compositions that demanded depth. Plagioclase zoned from sodium-rich centers to calcium-rich rims where growth tracked changing melt supplies. Zircon crystallized at the right times and trapped trace elements that reported on melt temperatures and water content. Quartz and feldspar locked into mosaics that revealed the pace at which the crust cooled. In some places, late fluids threaded the texture and left tourmaline needles and muscovite flakes as signatures of a system drenched in hydrothermal exchange. From above, the geography favored complexity over drama. Low domes with pale shoulders sat among dark belts that curved around them like braided rivers frozen in stone. Narrow straits separated nearest neighbors. Fresh fans flared at the mouths of short valleys. Offshore, ridges sketched luminous lines in thermal contrast. The world did not yet offer the height of future mountain chains, but it offered platforms large enough for winds to run, rains to pool, and sediments to settle in peace between storms. The archipelagos multiplied as the engine cooled. With each addition, the average height rose a little more, and the persistence of land increased. On a particular island, rain tapped a steady rhythm on feldspar blocks and ran in clear rills that turned milky downstream where clay joined. At a curve, the stream lost slope and laid a bar of bright sand shot with pale flashes of plagioclase. A ledge above the bar glowed pink, where a trongemite sheet had weathered to a skin. To seaward, a dark belt of amphibolite rose into a low ridge and fell again, its schistose planes catching light like brushed metal. Beyond the surf line, a rake of dikes pointed toward a source inland, narrow walls that guided the eye to a drainage crowned by a shallow caldera. The island looked young, but its foundations were already practicing endurance. Night landed with the assurance of a short spin. The moon lifted a path across polygonal coves. Waves struck pale domes and returned white in the dim. High in the sky, thin veils straddled stars and wrote rings around the brighter ones. The ground kept its warmth longer than the air, and mist pooled along the axes of basins. Under the haze, the archipelago remained a loose federation of floating keels and light shoulders, a map of buoyancy traced in igneous light. The mechanics did not need an audience. Mass managed mass, heat negotiated with cold, rock held the notes, water carried the tune. The moon stood impossibly large. A pale engine hung low over a world of water and steam. Craters still fresh from its own storms of stone pocked that bright face, their rims casting shadows long enough to touch imagination that did not yet exist. Its disk climbed from the horizon with the presence of a second world and laid a road of white across the ocean, a shining track that shifted with each swell. The light it offered was soft but insistent, a tide of brightness that ebbed and flowed with phases stretched over short nights. The sky seemed built to host it. The sea seemed tuned to receive it. Gravity wrote the deeper language. The pull of that nearby companion bent the planet's skin twice with every spin, a pair of bulges that marched under the moon and the point opposite. Ocean followed, yes, but stone did too, breathing by millimeters in a slow inhale and exhale that ran through bedrock. The breathing mattered. Flexure opened fractures, closed them again, and pumped fluids through rocks along hidden paths. Vents along submarine ridges sighed in step with the cycle. Hot water rose slightly warmer at certain hours and a little cooler at others. The rhythm translated into chemistry that arrived like clockwork on the seafloor and like a machine at the coast. Tides were not modest. In narrow straits, the sea reared like an animal and thrust inland as a rolling wall. The surge raced up channels that a map would later call rivers and flung foam against basalt sills with the certainty of a piston. In broad embayments, water sloshed on its own schedule, sometimes in time with the moon, sometimes setting up beats that beat against it. Boils formed where opposing currents wrestled. Eddies spun off the main flow and carried pockets of chemistry into quiet corners. When the tide turned, the sea retreated with equal force and left behind a city of pools arrayed by height. Each tier kept its own rules for an hour before the next cycle rebuilt them. Along certain coasts, the tidal front climbed in a single smooth face, a bore that announced itself with a hiss and then a blunt, running fist of water. It ripped through sandbars and left them cleaner than before. It lifted rafts of pumice and settled them higher than mere waves could manage. It carried silts into slots and lodged them there, then stole them back on the next retreat and left bare ledges ready for films. In meandering inlets, reflected waves piled into standing trunks of liquid that leaned and righted themselves like trees in wind. The entire shoreline behaved as a laboratory with a clock. Concentrations rose and fell to a metronome born in the sky. The day itself hurried under the moon's regimen. Sunlight crossed the heavens and left quickly. Shadows moved with energy. The shortness of rotation made tides arrive with little pause, a repeating pulse that rebuilt interfaces before reactions had time to exhaust themselves. Pools warmed under noon's copper and chilled under night's grey. Salinities climbed as evaporation worked between visits and plunged when the returning sea remixed everything. Films grew thick enough to wrinkle, then thinned under fresh water, then puckered again when brine returned. The cycles etched memory into rock as rinds, varnishes, and laminations thin as fingernails. Currents in deeper water also took orders from the moon. Over sills and submarine ridges, tides accelerated and tore laminar flow into turbulence that reached far down. That mixing hauled cold water upward and pressed warm surface water downward, a transaction that blunted extremes and ferried dissolved gases between layers. Internal waves, tall as mountains if they could be seen, proceeded along density boundaries and broke where slopes intervened. When they collapsed, they stirred bottom sediments into drifting veils that traced the rhythm in grey. A century later, those veils would be sandstones and shales with fine varves, but for now they were clouds that carried metals and organics into new company. Even the air kept lunar appointments. Atmospheric tides, raised by the heating of day and the cooling of night, interfered with the gravitational tide, sometimes agreeing, sometimes arguing. The agreement encouraged quiet regions where fog formed over warm water, in time to press a lid over nocturnal cooling. The argument sharpened winds in the hour before dawn and roughened the ocean skin so that evaporation spiked and clouds rose. Storms sensed these changes as slight gifts of energy, enough to shift an updraft from try to succeed. A tower that might have failed grew an anvil and shaded a basin by midday. The tie between sky and sea tightened by a body that never touched either. The moon's sheer size delivered spectacles that would have overwhelmed a later observer. Eclipses occurred often. When shadow crossed the sun, the world dimmed in mid-afternoon and temperature hiccuped downward. Winds altered their paths across the cooled patch and drove narrow fronts ashore. Birds were absent, but the ocean heard the change as a wrinkle in pressure that travelled outward and bent waves. On many nights, the moon grazed the horizon in such a way that refraction made it oblong, then stacked a mirage atop it, a phantom twin riding just above the reel. It set behind a serrated edge of low cloud and left the sea without its road for an hour until the reflected glow from bright cloud edges rebuilt a paler path. The tug on the planet's spin reshaped time. Each drag on the tidal bulge stole a sliver of momentum from rotation and gifted it to orbital distance. The moon crept outward day by day, an imperceptible gain in altitude paid for by longer days. The change was glacial by human standards and vigorous by planetary ones. As the day stretched, tidal ranges adjusted with geography, basins moved into or out of resonance, coasts discovered new rhythms, pool terraces stepped upward, then stabilized, then stepped again. The archive of those steps would one day be read as a ledger of slowing. Gravity's governance reached beyond water. The orientation of the axis wobbled and precessed, but the amplitude of its tilt stayed civilized. Without a companion, small changes could have grown large enough to swing climate between extremes. With a companion, the swing narrowed. Winters and summers existed as choices of heat and light, but avoided the wild. That orderliness gave oceans and skies an easier problem to solve. Feedbacks tuned themselves to steady beats. Ice margins learned to dance along familiar lines rather than march into quinquennial revolutions. At the sea floor, rock bent in time to the lunar drum and released energy as heat where friction acted. The warmth was modest compared to the furnace of the interior, but it was continuous and everywhere, a background subsidy that lifted temperatures in pores and along microfractures by degrees that mattered. In those narrow spaces, degrees meant hours added to reaction windows before cooling forced stasis. Minerals growing in veinlets recorded the timing as alternating bands that were not truly daily, but still rhythmic, a geological pulse signed by a light in the sky. The moon painted patterns in subtle light that trained the eyes of the ocean's surface. Earthshine lit the lunar dark and returned to the sea as a ghostly tint that changed night by night. New moon nights were black and dense, with stars peeking through rings and halos. First quarter nights wore a half road over the water and a knife edge of shadow across the face above. Full moon nights made coastlines look carved from silver and let films gleam like oil under noon, lightning backlit clouds into towers with ribs and knots. The path on the water sometimes split into multiple strands when small ripples bent the reflection like a comb. The splinters moved apart and together as swells crossed and cross-swells untied them. On certain shores, tides tuned chemistry into music. A pool near the height of usual reach received only spray for 2 cycles, then a brief immersion on the third. Its salinity climbed and fell in a sawtooth. Its temperature rose in daylight and did not reset at night until the sea returned. Films worked there in a cadence too brisk for continents but perfect for molecules. A lower pool drowned and drained with every turn. Its rhythm was steadier, its chemistry closer to the sea. A still lower bench stayed wet under a skin no wave could remove. There, brines stayed near constant and let reactions drift toward products that needed patience. 1 coast, 3 tempos. 1 moon, 3 metronomes. Cliffs heard the influence as low sound. Microseisms born from long swells and refracted tides shook rock and loosened grains that wind and water could then persuade to move. Along pebble beaches, stones clicked to the tide's breath and aligned themselves in arcs that lengthened, shortened, and shifted upslope in step with the strongest runs. On the scale of the planet, stone responded by warping and relaxing, and in the crust the repeated motion helped dikes find paths when pressure asked them to, as if cracks remembered which way was easiest. Not all consequences were gentle. In narrow fjords, the tide tore loose rockfalls from heated faces and brought them down in sheets. The plunge threw air into the water and seeded clouds of bubbles that changed the reflectivity of the surface for minutes. Off headlands, tidal jets accelerated until they built standing waves that disguised reefs below. The standing waves tugged at floating rafts, trapped them, then released them downstream in pulses. Rafts laden with pumice and salts broke there into smaller pieces and extended chemistry's reach by distance rather than depth. Season held a quieter conversation with phase. When the moon's path carried it higher, tides shifted their timing and height. When the path dipped lower, storms and tide bargained over the same hour. The negotiation showed up in banded sediments as pairs and trios of thicker and thinner layers. A future scientist would call them bundles and pull calendars from the patterns. For now, they were simply marks that the sea left on its own floors, beautiful in their restraint. A clear night brought a display worth a pilgrimage no creature could make. The moon hung huge and near and, for a moment, passed into the planet's shadow. The sea road vanished as if cut. Stars brightened. The bright face turned copper and then dimmed to ember through the haze of dust and droplets in the air. Temperature sank slightly. A ripple of wind ran outward from coasts as the cooled patch over water tugged nearby air. Minutes later, the first thin sunlit edge returned to the moon and rebuilt the path in silver. The tide did not care about color. It obeyed gravity alone and kept its count. By dawn, the moon had slid lower, closer to the horizon where refraction broadened it. It seemed to hesitate and then sank. The ocean, unpersuaded by theatrics, lifted and fell in answer to a pull that never forgot. Pools drained and pooled. Films tore and formed. The planet turned. The companions circled. Between them, the sea rehearsed in time, practicing persistence under a conductor made of light and rock. Stone kept a memory of movement, even when maps did not exist. Fabrics ran through old rocks like the grain in seasoned wood, preferred directions written by stress that had long since relaxed. Folds pressed layer against layer and then lifted their knuckles to weather, a slow ballet in mineral, Shear zones sliced pale domes with ribbons of darker rock that had flowed rather than fractured. In some belts, pillow lavas preserved their balloon shapes, yet leaned together like books on a shelf, caught in buckles, gentle at the surface and profound at depth. The planet did not confess its method, but the choreography suggested more than a single rigid lid. Heat set the rules at the start. Radioactive elements ran richer then, and the mantle sweated energy with far more enthusiasm than later ages. A hot interior softens the crustal lid, making it harder for long slabs to stay cold and strong as they dive. Without cold strength, subduction loses its sword and gains only a folding fan. That logic argues for a stagnant lid, a planet-wide carapace that crept and domed and sagged but rarely swallowed itself in clean trenches. Yet some rocks muttered otherwise. Dense basalt altered at high pressure into eclogite leaves, a fingerprint that says depth and force. Eclogite is heavier than the mantle that made it. Where it forms in sufficient volume, it wants to sink. If sinking began, a door opened to a different style of recycling. Archipelagos of ancient crust kept clues in their cores. Tonalite trongemite and granodiorite rose as light survivors from a sea of basalt. Their chemistry betrayed partial melting of hydrated basalts at depths where pressures ran high and water lowered melting points. How did those basalts acquire water? Rain and sea delivered it into fractures. Vents returned it in steam, but to hydrate deep mafic rock efficiently, it helps to press it downward. Some provinces looked as if narrow strips of crust had sagged between stronger blocks and carried their water with them, a drape rather than a dive. Subduction drew dark keels down and let pale shoulders float higher. It resembled subduction in appetite for density contrasts and differed in pose. In other terrains, the record was sterner. Amphibolite hemming greenstone belts spoke of heating and squeezing at mid-crustal depths. Garnet grew with chemistries that demanded pressures higher still. Zircon trapped trace elements, whose balances implied melts, born from sources altered and recycled more than once. Hafnium isotopes in those zircons aligned along trends that required early extraction of continental material from mantle and then repeated reworking. A lid that never broke would struggle to explain such persistent exchange. It seemed more plausible that the surface experimented with episodes of sinking and return, short subduction runs that lasted a few million years at a time, separated by quiet breaths where doming and drip fed the engine from below. Drips happen when the base of a thickened crust transforms into a mineralogy denser than the mantle and peels away under its own weight. The falling root drags hot mantle upward to replace it. The upwelling melts. The melt lightens the crust it invades. This cycle has no need for a single continuous plate. It needs only contrast and time. In rocks that once sat beneath early domes, seismic textures frozen in mineral alignments told of flow directions consistent with such overturns. The surface response to a drip is uplift and then collapse, basin opening around the edges, magmas of mixed parentage, and belts of deformation that curve like smiles or frowns around the center. All these marks appear in ancient provinces that later continents would stitch together. Classic oceanic signatures were rare in the oldest crust. Ophiolites, the neatly layered ornaments of later subduction, almost never survived from those days. Blue schist, the low-temperature, high-pressure rock that loves cold slabs, was absent because the planet had not cooled enough to permit its particular recipe. Instead, metamorphism ran to amphibolite and eclogite. That pattern is consistent with a hot earth attempting subduction with soft implements. Slabs grew warm as they descended. They altered and thickened. They stalled and tore. Pieces fell away and sank as dripping anchors. The leftovers rose and spread as domes and keels. The result was a patchwork of processes rather than a single regime. Experiments at pressure and temperature added weight to the story. Olivine and pyroxene, the workhorses of the mantle, weaken when wet. Water hides within defects and lets atoms slip past one another with less resistance. Diamond anvil cells and deformation rigs showed this plainly. If fluids can reach the mantle wedge above any style of descent, melting increases. If melting increases, light magmas rise and stitch the surface with pale rock. Old terrains abound with these stitches. The implication is that fluids reach depth often, whether along shallow drapes or steeper faults, and that melting rewrote the crust repeatedly. The growth of thick, buoyant roots under the earliest stable blocks told of survival strategies. As felsic crust accumulated, it cooled. As it cooled, its base grew rigid and dry. Peridotite beneath it froze into a refractory keel depleted by earlier melt extraction. This keel was lighter than surrounding mantle at equal pressure and temperature, so it floated. Such cratonic roots shielded the overlying crust from later wholesale recycling. Diamonds formed in some of these keels at depths unheard of for ordinary mountains, their ages reaching back to early chapters. Their mere presence argued for long-lived mantle architecture capable of resisting overturn. Stability at the center and experimentation at the edges make a plausible pair. Modelers set broader boundaries. Take a mantle hotter by hundreds of degrees. Decrease viscosity by factors that represent both temperature and water. Increase heat production by early radioisotopes. Let plumes rise from depth with more vigor. Under such conditions, plates as seen today struggle to remain coherent. Instead, the lid domes breaks locally, founders in drips, slides along shallow detachments, and occasionally organizes into short zones where a slab dives and then loses strength. Call it episodic subduction. Call it a hinge that starts and stops. The rock record cannot settle the name, but it supplies the texture. Granite greenstone provinces displayed the argument in plan view. Light domes of felsic rock stood like islands within belts of metamorphosed basaltic and sedimentary sequences. The belts folded around domes in patterns that implied flow of darker rocks downward and lighter rocks upward. Structural geologists traced shears that dipped into the keels and rose again. Low-angle detachments that allowed crust to rearrange itself laterally while accommodating vertical motion. The belts included sequences laid in basins that opened and closed quickly, filled with volcaniclastics, chemical sediments, and tholetic lavas. The pace suggested tectonics that worked on shorter pulses than later plate circuits, but still cared about boundaries and motions. High magnesium lavas recorded a mantle too hot to ignore. Komatiites erupted thin and wild. Where they pooled, they quenched into plates of bladed crystals that pointed away from cooling fronts, a frozen clock of flow. Their prevalence declined as the planet cooled. That decline coincided with an increase in the volume and persistence of felsic crust. As light crust spread and thickened, it absorbed stress and focused deformation into belts. The system drifted toward a more plate-like behavior by degrees, not by proclamation. Erosional products told a quieter story. River sands with their mix of minerals changed as felsic rock joined the supply. Early sediments carried more volcanic glass, more pyroxene, more olivine. Later ones gained more quartz, more feldspar, more lithic fragments from recycled crust. The chemistry of muds evolved in step, with ratios that spoke of intensifying weathering on land surfaces that lasted long enough to build soil. For tectonics, this mattered. Landscapes, durable on geologic timescales, require a surface scaffold that does not vanish with every plume or drip. Strengthening keels and widening felsic platforms gave rain and rivers room to do persistent work. Magnetism preserved as remnants in ancient iron formations recorded how blocks moved relative to the field. Directions varied within individual belts in ways that demanded rotations and translations after formation. Some rotations were large, some translations were lateral. Neither aligns with a world of purely vertical drips. Lateral movement implies boundaries that accommodated slip. Faults found low friction zones and allowed rafts to slide past one another. The motions were not necessarily steady nor world-encircling. They were enough to populate basins, align arcs of volcanism, and stitch belts into collages that later sutures would emphasize. The question of beginning misleads by asking for a moment. Machinery of this scale warms into operation rather than snaps into it. A hot lid domed, draped, and dripped. Eclogite formed and urged motion downward. Fluids lowered melting points and encouraged reworking. Short subduction runs initiated, broke, and resumed. Felsic crust accumulated and toughened. Roots grew and anchored. Lateral sliding found preferred horizons. Over hundreds of millions of years, experiments converged toward a mode more recognizable as plates with trenches and arcs that persisted. The earliest rehearsals were messy, the later acts ran longer. A traveler across an old terrain would not have seen lines on a globe, but would have felt structure in the ground. A valley followed a greenstone belt where dark rocks softened under weather and where schistose plains offered steps to water. A ridge traced a pale dome where quartz and feldspar rang under hammer and held slopes clean. An outcrop exposed a shear zone, polished by long movement, its micas aligned like fur brushed in one direction. Across a river, a lens of eclogite glinted with garnet eyes, a small witness of depth and return. The landscape was a book of verbs: bend, flow, sink, rise, slide, stitch. Night arrived with a brisk rotation. Stars turned behind thin veils. The ocean muttered at the foot of domes that had learned to float. The mantle held its heat but a fraction less than the year before. The crust cooled by degrees and grew stronger in patches. Somewhere a drip detached, somewhere a short slab tried its angle and failed. Somewhere else a quiet basin opened and admitted ash and sand. The planet kept experimenting. Movement did not need a single law to begin. It needed gradients. It needed time. Darkness did not quiet the planet. Beneath crust and mantle, iron moved in patterns no eye could find. A river caged inside pressure. The core had gathered early when the surface still smoked, metal separating from rock like oil from water, then falling inward through a storm of molten silicates. Once pooled at the center, it did not rest. Heat bled outward into the mantle. Light elements adulterating the iron rose as invisible fog. Heavier liquid slid downward. Motion organized. A magnetic field emerged, as if written by a hand that knew only spirals and loops. Night above gained a faint ceiling of protection below. The recipe asked for 3 gifts: conductive fluid, rotation, and energy to stir the fluid into helical motion. The planet had all 3 in abundance. Liquid iron and nickel, salted with sulfur, carbon, silicon, and oxygen, filled most of the core volume. The spin of a short day curled, flows into columns aligned with the axis, a Coriolis architecture that guided eddies into order. Energy arrived as heat escaping into the mantle, and as chemical buoyancy from light elements expelled during metal segregation. Together they drove convection, not as boiling bubbles but as rolling sheets and spiraling plumes that threaded the core from the center to its outer skin. An inner solid heart had not yet crystallized to any large volume. That later engine, which would push buoyant light elements outward as it froze, remained a promise rather than a contribution. The early dynamo drew chiefly on thermal gradients and the compositional stratification born from metal separating out of silicate and then unmixing within itself. Each parcel that rose carried a small deficit of density. Each parcel that sank replaced it with a heavier mix. The dance worked only if the mantle let heat pass. A mantle running hot can behave like a blanket. If too much insulation gathered at the base, convection would slow. The rock above obliged with just enough permeability to drain the core of heat and keep the motions honest. Impacts may have lent sudden punctuation to this steady script. Large intruders arriving late could jolt the core by delivering angular momentum or by shaking density gradients into new alignments. After such an event, flow lines would rearrange, and the emerging field might wobble or reverse. Even without collisions, reversals could have taken place as the system wandered through states allowed by its physics. Field lines looped and folded until they tangled into instability, then snapped into a new configuration, the poles moving with a swiftness that would have astonished any later navigator. The rocks that cooled at the time trapped the direction like compass needles set in stone. Above the core, the mantle imposed its own tempo. Where plumes rose, heat flux across the core mantle boundary increased. Where large slabs, or their early equivalents, sunk and pooled, the flux peaked differently. The result was a patchwork of hotter and cooler regions at the base of the mantle that impressed preferred longitudes on core convection. A map of the field would have shown broad sectors stronger than others, not random but guided by thermal mosaics. The core was not a world apart. It answered to the slow exhale and inhale of rock over it. Electrical conductivity in iron alloys grows with pressure and purity. At depth, the liquid carried current with elegance. As fluid moved across a pre-existing magnetic field, inductive coupling strengthened that field. The strengthened field, in turn, steered flow into spirals that sustained induction. The self-consistency of a dynamo carries a quiet beauty. Motion makes field. Field shapes motion. Break the loop, and the field decays on a timescale set by diffusion. Feed the loop and the field lives, not invulnerable, not permanent, but persistent enough to span eras. At the boundary with the mantle, a layer may have formed where motion slackened. Chemical gradients can build a stratified pond of iron-rich fluid that moves more by waves than by overturning. Such a layer filters the field, smoothing small-scale features and letting long waves pass. Evidence for it would hide in how quickly the field changed from place to place above. In an early world, with hotter boundaries and stronger composition contrasts, the layer could have waxed and waned. When thin, core patterns reached the surface more directly. When thick, the field looked cleaner, but hid its intricacies under a varnish. The magnetosphere, born of these depths, stretched into space like a teardrop facing the star. On the day side, it pressed inward where solar wind rammed it. On the night side, it pulled out into a long tail where field lines were dragged away. Reconnection events in that tail accelerated particles back toward poles. There they dove into the upper air and drove colors through thin, breathable layers that had nothing to do with breath. Green from oxygen, high and rare. Red from oxygen, lower and more crowded. Violet from nitrogen in a flurry of collisions. Curtains hung low in a young sky, rippling to the rhythm of a field written by iron far below waves and rock. Protection mattered. A star in its youth sends tantrums often. Without a shield, ion pickup would gnaw at the top of the atmosphere, dragging hydrogen away and scouring lighter gases with it. With a shield, the worst of that wind was pushed aside. Energy dissipated along field lines and at boundaries rather than everywhere at once. Escape still happened. No magnetic field can bottle an atmosphere forever, but loss slowed. Water vapor photolized in the upper air still sent hydrogen upward. Some escaped, some returned. The balance tilted toward retention. Oceans kept their mass. Clouds kept their cycles. Chemistry had time to grow intricate. Remnants preserved the field's story where iron minerals cooled through their Curie points. Basalts that rose at ridges locked directions into tiny magnetite grains. Ash that settled in basins did the same as it welded. Even single crystals of silicate trapped images of the field as microscopic inclusions of iron oxide lined up during cooling. Later heat could reopen those memories and write new ones. Later fluids could erase them, but a fraction survived. Those survivors spoke of intensities that were not feeble and directions that changed on timescales long enough to build landscapes and short enough to populate a lifetime of thunderstorms with variations in compass truth. Lightning itself felt the field. In tall storms, leaders reached downward and upward at once. The field biased some paths over others. Discharges propagated along routes that mirrored larger-scale ion drifts. Sprites and elves, those brief flashes above towers, mapped the coupling between storms and the ionosphere. In an atmosphere loaded with greenhouse gases and short on oxygen, the chemistry after a strike diverged from later recipes. The field did not control this chemistry, but it herded charged fragments into corridors where certain reactions became more likely. The magnetosphere, from core to airglow, was not merely a shield. It was a conductor's baton setting tempos in phenomena that began as weather. Heat sources in the core paid the bills. Accretional energy survived as warmth for a long interval. Radioactive decay of potassium and other isotopes within metal is debated by those who measure and model, but even without those contributions, the cooling of the core through a hot mantle and the separation of light elements from heavy ones furnished power. As the planet aged and the mantle stiffened, heat flux at the boundary could have dropped in places. The dynamo might have faltered there, only to recover when mantle convection reorganized or when the first crystals of the inner core began to form and compositional buoyancy joined thermal buoyancy with fresh strength. Reversals were more than curiosities. a field that flips rearranges where charged particles enter the atmosphere and how currents flow in the shell above weather. Such reorganizations alter auroral geography, influence where lightning couples most strongly to the ionosphere, and change the radiation environment at altitudes where no living thing yet flew. The ocean and rocks below would have noticed little directly. Magnetic minerals forming at those times would have taken their cues from a different north. The grander implication was that the engine tolerated a range of states. It did not fix on a single scheme and defend it. It explored variations inside the tight bounds set by physics. Friction where tides shook rock may have added a modest subsidy. The nearby moon pulled not only water, but also the solid earth into bulges that moved around the globe. As those bulges crossed roughness in the mantle, heat appeared, a faint warm breath compared to volcanism, yet significant in that it nibbled at the thermal budget at depth. Every degree counts where convection must remain vigorous. Impacts, too, redistributed heat by stirring the mantle and exposing fresh pathways for exchange. After a large impact, boundary heat flux changed patch by patch, and the core answered with altered patterns in flow and field. Elsewhere in the solar system, bodies without dynamos tell a cautionary tale. Thin fields or none at all correlate with atmospheres stripped to traces unless gravity alone can hold gas. Here, gravity helped, but the field helped more. It turned charged projectiles from the star into auroral art rather than into unrelenting erosion. It bought the lower air time. Time makes complexity cheap. Without hurry, reactions reach farther into possibility. A clear night presented the result as theatre. Auroras sagged toward latitudes that would later call them rare. They braided and unbraided, the fabric of field lines shaken by the star's breath. In their movements lay the shadow of currents 3,000 kilometers down, rivers of iron twisting under pressures that squeeze lattice into unfamiliar symmetries. A field line traced from a green curtain would have led through the ionosphere, through the mantle, and into a convecting shell where flow, guided by rotation, drafted spirals that made magnetism from motion. No creature watched. The world wrote its own insurance policy, in light few eyes could have endured, and in a language every charged particle could read. By dawn, stars thinned behind haze. The field remained, silent and practical. It accepted new solar wind with the calm of a veteran. It pulsed where reconnection demanded it. It diffused energy into currents that slipped along the upper air and settled. Far below, iron turned and turned, the dynamo still funded by gradients between inner heat and outer chill. The planet kept a night that was not merely absence of day, but an electrical country of its own, tended by a core that refused to cool without writing a sky in color first. The sea spoke in ions, not in waves alone. At its surface, a thin film organized the traffic of molecules like a customs gate, admitting light, rejecting some heat, and arranging salts into microlayers where charge ruled more than mass. Just beneath, carbon dioxide slipped into water and became carbonic acid, then split into bicarbonate and carbonate, with a balance set by temperature, pressure, and the stoic presence of dissolved cations leached from young crust. The ratio mattered. It decided whether carbon would hide as rock later or remain dissolved to lend the air its warmth. Basaltic shores fed the choice by surrendering calcium and magnesium to every drop that ran off their black faces. The sea took the gift and tested saturation minute by minute against the quiet arithmetic of pH. Oxygen did not guide any of this. It was a whisper rather than a presence, and so iron traveled free. Ferrous iron, reduced and obedient to solution, shadowed currents in concentrations high enough to give the upper ocean a greenish cast that swallowed blue. Where hydrothermal plumes rose along ridges, iron surged again, joined by manganese and trace metals carried in hot, acidic jets. Mixing with colder, more alkaline seawater forced some of those metals to flocculate into fine particles that settled like invisible snow, layering the seafloor in films so thin only patience could see them. Elsewhere, chemistry kept them dissolved long enough to move with water masses and tint distant basins. Sulfur wandered in another loop. Volcanic gases and hydrothermal fluids injected hydrogen sulfide and sulfur dioxide into air and sea. In the water column, sulfide met metals and made minerals with colors of midnight and embers, black and red and coppery, right at the mouths of vents. Farther from the heat, oxidation states shuffled in slower circuits. In an anoxic world, sulfate was a visitor easily reduced back to sulfide by reactions with iron, with organic fragments forged by lightning and light, and with hydrogen born from rock reacting with water at depth. The cycle never rested, even without biology to speed it. It ran by gradients and by the infant planet's fondness for transactions that released heat. Silica rode through the ocean as a quiet presence. Rivers carried it from weathered feldspars. Vents loaded it into plumes. At the mouths of chimneys, it precipitated as chalcedony and opal in thin skins that healed cracks and then cracked again. In shallow basins, evaporation persuaded it to bead along walls and to glaze grains with coatings that stiffened sands into proto-cement. The sea's taste changed with every storm that raised dust, every quake that opened a fracture, every eruption that spread new glass across the shoreline. Yet, through all the flux, the silica concentration kept within ranges set by temperature, and the sea's reluctance to supersaturate by much. Persistence of undersaturation kept space open for later lives that would build skeletons, though no such architects yet drew breath. Nitrogen filled the air, but arrived in water as a conservative guest. Without abundant oxidants, nitrate found little purchase. Ammonia appeared instead, where lightning and ultraviolet tore nitrogen and water into pieces, and where deep reactions in serpentinite belts released hydrogen to drive reduction. That ammonia dissolved readily and carried a different promise than nitrate, one that favored synthesis over combustion. Pools along coasts trapped it between tides and concentrated it alongside phosphate and metal cations into broths that dried, re-wetted, and dried again with a metronome set by the large moon. The sea fed those pools with patience, delivering micromoles in bulk, and letting concentration do what abundance could not. Phosphorus was scarce and potent. Most of it slept in mineral forms reluctant to part with their bonds. But meteor alloys shed reactive phosphate when they oxidized in water, and fresh basalt released small comforts of phosphorus when acids from the sky worried it. Hydrothermal fields offered carbon monoxide and methane, alongside ammonium and phosphate in ratios that changed with the whims of flow. In mixing zones along those fields, green rust formed, a layered double hydroxide of iron that trapped anions between sheets. Green rust gathered phosphate like a miser, and then, under the prompt of pH shifts or contact with sulfide, altered into other iron minerals, freeing part of its hoard in pulses. The pulses mattered more than the totals. Serpentinization wrote another chapter at the boundary of rock and sea, where ultramafic peridotite met water, olivine and pyroxene transformed into serpentine and magnetite, releasing heat and a steady supply of hydrogen. The process raised pH to alkaline values in confined spaces and set steep gradients against the mildly acidic ocean outside. At the margins of such systems, chimney walls of carbonate and brucite grew honeycombed with pores finer than a hair. Across the membranes separating inside from outstretched differences in pH and redox potential that acted like batteries without wires, ions climbed and fell through narrow throats. Minerals catalyzed slow reactions. Carbonate and sulfide surfaces nudged molecules into arrangements they would not choose in free solution. Carbon did not travel only as a gas and a bicarbonate ion. Reduced forms drifted as well, born from reactions in vents and from photochemistry at the surface. Sunlight partnering with ultraviolet split and stitched carbon chains in the first millimeters of water during clear intervals, then handed the products to foam. The foam beached and left films that dried to skins and then to flakes. Flakes returned to solution with the next tide and met metals that changed their fates, bridging carboxyls and amines into clumps, then tearing them apart again as pH swung and as chloride ions argued for control. The ocean was not a cauldron, it was a broker, setting tables and moving participants between them on schedules kept by wind, tide, and geology. Acidity and alkalinity fought to a draw in most open water. Rain injected carbonic acid. Basalt yielded cations that neutralized it. In shallow flats under clear skies, evaporation raised salinity and forced some carbon into minerals that coated grains like frost, then failed when fresh water returned. In deeper water, pressure favored dissolution and kept carbon mobile. The net effect buffered the ocean against wild swings. That buffer saved heat budgets because a sea held near neutral to slightly alkaline takes up carbon dioxide differently from one that swings among extremes. Climate leaned on chemistry long before biology learned to pull hard on the same levers. Trace metals wandered like secret couriers. Nickel complexed with organics, stabilizing some against hydrolysis. Cobalt and copper toggled between oxidation states that could pass electrons along mineral surfaces and within pores. Molybdenum, rare and precious in an oxygen-poor sea, hinted at a future it would later dominate in enzymes that did not yet exist. Arsenic changed form as redox nudged it, sometimes behaving like a phosphate twin, sometimes evading the nets that caught its cousin. Each metal changed solubility with pH, chloride activity, and sulfur presence. The map of availability shifted with every plume and every rain, a fractal of opportunity. Banding began invisibly, where an anoxic interior water mass met a layer altered by photochemistry or stirred by storms. Iron oxidized along a moving surface and settled as thin laminae of ferric compounds that later metamorphism would compact and recrystallize into rock. Between those laminae, silica and carbonate laid their own gauzes. The alternation recorded not seasons but pulses of mixing, shifts in basin ventilation, the dance of stratification under tides and winds. The sea wrote its diary in rust and glass, delicate at first, then thicker as circulation and chemistry found recurring tempos. Gases above water set ceilings and floors for what dissolved below. Methane hazes thickened and thinned with outgassing and with the star's mood. When thick, they shaded surface waters and softened ultraviolet reach, slowing some photolyses and allowing the top centimeter to cool a degree or two. When thin, they admitted harder light and forced the surface back into a reactive frenzy. Carbon dioxide held steady in the aggregate, but varied along coasts where weathering pulses and volcanic breaths argued. Hydrogen diffused upward and escaped, trimming the reducing strength of the sky by threads rather than ropes. The ocean translated these fluctuations into small shifts in pH and redox that nevertheless tipped local chemistries toward products on one week and toward substrates the next. Deep circulation carried inventories from ridge to ridge. Vent fields did not produce identical plumes. Some ran acidic and metal-rich, others ran alkaline and hydrogen-laden. As their waters spread along density surfaces in the mid-ocean, they injected distinct signatures that persisted for tens to hundreds of kilometers. Where two layers met over rough ground, they mixed into hybrids that seeded new particle growth. Those seeds fell and formed drapes across topography. They fed quiet seeps with catalytic surfaces. They built platforms for later precipitation and for films that needed a gentle anchor. Lightning put its own stamp on seawater. Discharges over spray punched channels of hot plasma into humid air, forging nitric oxide and other reactive species that dissolved in droplets and streaked downward into the skin of the sea. There, nitrosyl groups and peroxides met iron and sulfur and rearranged suites of dissolved species in hours. The effect fell off with depth, but the surface reset mattered. It primed the next tide of foam with functions it had not possessed the night before. It slightly altered the solubility of metals at the interface. It biased what films would trap and what they would ignore. Sound could have been used to map chemistry if ears had existed. Plumes from vents altered density and temperature, changing the speed at which waves traveled. Internal waves modulated by tides shifted layers and with them the refractive properties of water. A sensitive instrument would have heard sheets of metal-rich water gliding like quiet thunder across a basin. No such instrument stood watch. The map remained implicit, inscribed in mineral threads and in the way light scattered when a beam angled down from a gap in the clouds. Toward evening, the top millimeter of ocean cooled faster than the water below, a skin that thickened into a lid and reduced gas exchange by small percentages that compounded over hours. Mist formed where cool met warm and dropped back faint rain that contained the day's collection of acids and metals. The first meter breathed out less carbon dioxide than it had at noon and held more heat than it admitted. The sea saved energy for night. Chemistry slowed a fraction, then accelerated again under the moon, then paused at dawn, then resumed. No creature marked the schedules, yet the elements obeyed them with grace. The ocean nested complexity inside gradients and let time pull structures from chance. It did not hurry, it did not rest. Light felt handmade and slightly dangerous. The star lifted a pale blade above the horizon, and the air bent it into colors that did not yet carry names of comfort. Short wavelengths scattered into milk by dust and droplets. Long wavelengths pushed through, thick and warm, painting dawn in burnt copper and pale brass. The sky never settled into a steady blue. It wore veils of methane haze and sulfate dust that braided brightness into soft glare. On some mornings, the sun looked like a coin pressed behind frosted glass. On others, the haze thinned enough to show a wan dome that hinted at blue the way a memory hints at music. Ultraviolet arrived with few guardians. Without a generous ozone column, hard photons walked to the ground and set work upon water and rock. Surfaces responded as if under a strange kiln. Film at the top of tide pools browned into thin lacquer, then cracked into scales under a noon that felt metallic. Drops beaded on fresh basalt, each one a lens that concentrated light into miniature furnaces along its rim. Quartz grains glittered and then dulled as thin skins formed and peeled. In shadowed coves, the UV furnace softened to a glow, still enough to write into brine and leave radicals with strong opinions about what bonds should hold. Clouds redeemed and complicated the day. Convective towers rose and spread anvils that turned noon to late afternoon and drew bands of cool across water and stone. Their undersides wore bruised violets and greens when sunlight filtered through water-rich decks. Stacks of ice crystals above the anvils built halos around the sun, a white ring that widened and narrowed with crystal size, sometimes splitting into bright-side dogs that hovered like twin stars at equal heights. Beneath the display, rain fell in curtains that never quite hid the bright horizon beyond, each sheet catching light and returning it as silver gauze. Lightning replaced geometry with insistence. It leapt from cloud to cloud and from cloud to sea, then, in rare upward strokes, rose as luminous spears toward the upper air. The discharges forked through a mixture rich in carbon dioxide and nitrogen, leaving nitric oxide and other brief actors to dissolve into droplets and hurry downward. Above the thick weather, sprites bloomed as red veils and rings, electrical flowers that opened for less than the blink of an eye. Elves spread as pale discs that expanded and vanished. The spectacle revealed a possible ladder between sky and space, a ladder climbed by charges rather than by feet. Mirage wrote tricks over long reaches of warm water and newly cooled stone. A low island sharpened into a cliff 1 hour and melted into a hovering slab the next as temperature gradients inverted in the air. The sun's rim, smeared by layers of differing density, lifted a thin green flash at the last beat of dusk. On clear evenings, a stack of refracted images piled above the setting disk, a procession of phantom suns tinted by haze. The moon, large already, sometimes grew a soft duplicate just above itself, a parhelion's cousin born of ice plates, oriented by light winds high in the atmosphere. The color of shadows told the story of particles. Under thick aerosol canopies, shadows carried green and violet tints instead of neutral grays, a signature of scattering that disfavored blue yet never surrendered it entirely. At noon, the ground glowed with a cold luster as if light had been liquefied and poured across it. The sea, iron-rich and reluctant to sparkle, reflected in patches like hammered metal. Where spray lifted, the spectrum shifted a hair toward blue, an accidental kindness delivered by the shortest wavelengths, finding a path through short-lived clarity. Ultraviolet sculpted chemistry in plain sight. At the edges of pools, molecules aligned along mineral surfaces and took energy directly from light, forming rings and chains that survived long enough to meet others in the next pulse of tide. When a cloud crossed the sun, reaction rates dipped, and some products disassembled back to their fragments. When the anvil moved on, the furnace relit, and different bonds became favorable. The day imposed a cadence on reactions measured in minutes. Night inverted the ledger. Radical lifetimes stretched. Diffusion regained influence over the sudden edicts of photons. Films softened, absorbed moisture, and changed their solubility, preparing a new stage for the morning. Colors inflamed horizons before storms. Dust and sulfate droplets thickened the lower atmosphere and split light into rails of orange, carmine, and brownish gold. Taller towers overtopped the haze and bore crowns that shone like alabaster. A single bolt stitched the scene together. For a second, a three-dimensional skeleton of the storm stood on display, channels branching into fractal candled ribs. Thunder took its time to arrive in the thick air, rounded and resonant, as if someone had struck a great skin and let it hum. Night did not mean darkness. Airglow painted the sky with quiet chemistry, an emerald wash from oxygen recombining high above and a softer red along bands drawn by hydroxyl. Meteors threaded the upper air and left sodium wakes that persisted as faint amber strokes. Auroral curtains wandered down the latitudes, draped in green with violet hems, the evening's answer to the stars' daytime pressure. The moon laid a path along the sea, a long sash that parted on swells and rejoined in troughs. Mist formed in low places where warm ground met cooling air and gathered moonlight like cloth woven from breath. Halos became calendars. A tight ring around the sun warned of uniform crystals and steady layers aloft. A pair of bright mock suns at equal distances promised plate-shaped ice and then delivered. Crossed pillars rose above the moon when falling crystals fluttered and settled with a bias, their flat faces reflecting a column. Coronas around bright points said droplets were small and similar, a signature of laminar layers and gentle shear. Iridescence along cloud edges exposed wave motions, weak undulations rippling through decks that pretended to be still. The vault displayed a bureau of optics that required no language to read, only attention. UV, left to its own discipline, decorated basalt beaches with chemistry that was almost color. Thin films shifted from straw to umber as depths changed. Skins wrinkled into polygonal maps that matched cooling cracks beneath, a palimpsest where light drew on the same lines that heat had scored. Pumice, bleached by a few bright days, softened to pearl grey and released fine dust that flashed briefly in oblique beams, then fell back, glowing for a breath. In that dust lay catalysts and poisons together, metals in forms ready to bind, release, and bind again as acidity and redox swung under the day's hand. Storm light trained perception toward structures. Mammatus pouches hung from decaying anvils like inverted hills, each cell boxed in by gradients of temperature and water. Virga fell as ghost rain that evaporated before it touched the ground, carving ribbons of cool air that rolled into microfronts. Sunbeams slanted through the gaps and cut the sky into bright corridors and dim galleries. In those galleries, the sea darkened by degrees, a topography of light revealing current lines, Langmuir streaks, and rip zones over shoals, legible from heights only birds would someday command. At polar edges, low sun grazing through haze fattened into a ruddy ball during long twilights. The disk deformed as layers of air stacked their refractive power, the way a lensmaker stacks glass. Bands of color separated and recombined. The horizon turned razor-thin and glittered with minor mirages that cycled in seconds. Ice, where it formed seasonally, mirrored the sky's metals in pale copper and weak gold. Leads opened and closed to the slow breathing of tides, and the reflected path of moon and sun hopped from lead to lead as if searching for a perfect mirror. In mountainless country, light found drama in small relief. A new lava surface, black and warm, pulsed in shimmering waves as heat rose and bent angles of view. Floating rafts of ash cast smeared shadows lighter than night but darker than day across coves. Against those shadows, spray hung in prisms. Rainbows tried, and failed to arc beyond a hint, their colours washed to pastels by the fine grit in the air. At the perimeters of storms, crepuscular rays spread like ribs from a bright heart, each beam a region where light passed, each dark lane the geometry of shadow and scatter, a diagram of volume painted on air. The eye that did not exist would have squinted often. Meanwhile, surfaces took the messages without protest. Minerals accepted photons, changed states, bumped electrons along, and reset to be asked again. Water's skin thickened and thinned, absorbing light at some wavelengths and returning it with altered phase at others. The upper centimeter of sea served as both window and wall, admitting heat under steep suns, reflecting it under low ones, and doing both during broken cloud afternoons when mosaics of shade and shine drifted like continents of light. At midnight, when even high airglow softened, a distant storm flashed silently over the horizon, a pulse that painted cloud interiors like paper lanterns. The auroral band wavered once and steadied. The moon slipped behind a thin deck and traded its white road for a wider, dimmer sheet that turned the ocean to polished granite. Stars expanded halos and then focused again as turbulence ebbed in the upper layers. The silence said nothing about inactivity. Far above, molecules met and parted. Far below, currents turned. The theater of photons dimmed and shifted acts without closing. Dawn came as a gradient rather than a line. Black admitted blue-grey, then pewter, then copper. Hayes remembered the night's chemistry and let the shortest wavelengths in first, only as a whisper. The sun breached and rubbed brightness along the undersides of low decks until they glowed like banked coals. Drops condensed on windward faces and drew wet lines that glittered for a moment before the air reclaimed them. The new day reset exposures and started the reactions that heat, light, and time preferred. It did so with elegance rather than mercy. The light was alien, but the rules were familiar. Energy arrived. Matter answered. Evidence arrived as whispers in stone rather than voices. A dark fleck encased inside a crystal smaller than a grain of sand carried carbon atoms that weighed slightly less than their cousins. The difference was not visible, yet it tilted a scale inside a spectrometer, a tug that urged suspicion. Light carbon can come from heat and rock alone, but it can also come from appetites. If a metabolism had ever set its preference into a lattice, it would look like this. The crystal had sealed that fleck as if hiding a secret inside armor. Its edges were still sharp after journeys that would have erased almost anything softer than diamond. The numbers did not shout. They tugged at the imagination until it turned. Other rocks told the story more openly. Layers rich in iron and silica lay stacked like pages of an ancient ledger. Between the bands, thin laminae hinted at pulses in chemistry that might repeat if a shallow basin received occasional breath from deeper water. The iron had oxidized without abundant free oxygen in the air. Perhaps ultraviolet light had split water at the surface and left reactive forms behind to do the work. Perhaps microbes had learned to exploit iron's willingness to trade electrons. The rocks did not attach names to their authors. They only displayed traces of transactions. Carbonate veins held graphite in thread-like wisps and nodules. Some threads lay along fractures where fluids had once moved. Others sat inside grains that grew in place. The graphite skewed toward light carbon again, a bias that begged for a partner to explain it. Heat alone can push isotopes apart, but the patterns in certain rocks looked as if something had sorted them at lower temperatures than metamorphism could supply. A laboratory heats carbonates and watches carbon redistribute. The fractionations line up differently. A living process makes choices grain by grain. The graphite hinted at choices. Shallow mounds of layered stone rose out of some ancient sequences and wore textures more often associated with reefs built by microbes. Concentric laminae undulated like pages in a weathered book. Columns branched and rejoined. Pockets looked like bubbles captured and then stilled. The geometry resembled forms that later organisms made with confidence. Yet hot, alkaline water can sculpt minerals into deceptive echoes. Crystal habits can mimic biology with alarming talent. Storm surges pressed into soft mats leave ripples that read like growth rings. The mound stood at a crossroad where biology and physics shared the same handwriting. Sulfur, in old sediments, bore a different accent, one that spoke from the sky. Isotopes arranged themselves in ways that ignored the usual rules of mass. The pattern required ultraviolet light acting on gases high in an atmosphere thin on oxygen. It also required surfaces or solutions where those products settled and recorded their history. Such signatures form naturally in a sunlit world without much ozone, and they can persist whether or not metabolism joins the dance. Later, when oxygen rises, the odd patterns fade because an ozone layer steals the responsible wavelengths. The shift from unusual to ordinary served as a border. On the near side, light wrote chemistry directly into air and water. On the far side, something else did more of the writing. In rocks near ancient hydrothermal fields, filaments of iron oxide curled and branched along tubes within layers of quartz. Their scales were delicate, their repetition suspiciously regular. Hot springs produce precipitates with structure. Chemistry alone can make tubes and filaments where fluids move through fine pores. Yet the filaments resembled forms grown by microbes that farm iron in modern vents. A thin section under crossed polarizers glittered with clues too subtle to settle a verdict. The stone carried plausible shapes and a history of heating and deformation that blurred edges. The balance tilted back and forth, as if undecided. Phosphate, a currency of later cells, attended the scene in small subsidies. Meteoric alloys, weathered in water release, reactive phosphorus from mineral forms that do not mind giving up electrons. Lightning strikes into bursts of spray, make nitric oxides that drift into pools and invite phosphorylating reactions. Basalt under acidic rains grudges a modest stream of phosphate into rivers and then to sea. Concentrated in tidal flats or alkaline vents, phosphate discovers partners ready to assemble chains. The mineral record does not show molecules, it shows the ledgers where they could have been issued. A preference for one hand of a molecule over the other, chirality, haunted the arguments. Rocks do not express such choices easily, but surfaces of certain minerals bias orientation. Light passing through fogs of chiral vapors acquires a twist. Ice recrystallizing under polarized light can favor one mirror over its twin. None of these mechanisms demand life. All of them could serve one that learned to multiply. Later times would find certain sugars and amino acids consistently leaning in one direction. Here, in the deep past, signs were faint, like footprints washed by returning tide. Some meteorites carried slight biases in amino acids. If similar biases accumulated in pools or pores, they could have nudged sequences into order. Stones could not testify to that directly. They merely supplied the stage. Ribose, that temperamental sugar at the heart of one familiar information carrier, suffers in heat and acid. Yet in the presence of borate, it behaves with greater dignity. Borate grows more available as felsic crust weathering increases. Early islands of light rock would have fed streams with boron. Clay minerals, layered and hospitable, offer pockets where sugars and bases can rest. Iron sulfides create gardens of voltages at grain boundaries. Carbonate chimneys issued pores with pH differences as sharp as walls. Into this maze drifted cyanide, born from impacts and ultraviolet chemistry, methane and carbon monoxide from vents, ammonia from lightning and rock. The terms gathered and combined in sequences that small gradients could drive toward unlikely products. When heated waters met colder seas along vents that built carbonate towers, membranes formed at boundaries, mineral films one molecule thick that separated inside from outside. Across such films, hydrogen ions fell in one direction more readily than the other. The fall constitutes work if it can be caught. Today, cells thread proteins through membranes to catch that energy. In that age, pores with metal sulfide walls could do some catching without proteins. Electrons moved along minerals and catalyzed reductions familiar to modern methanogens and acetogens. The stones did not prove that such metabolisms existed. They proved that the physics and chemistry required by those pathways appeared in towering abundance. Methane appeared in ancient fluids and atmospheres by several means. Rock meeting water at high temperature makes hydrogen. Hydrogen meeting carbon monoxide reduces carbon. The result is methane and a little heat to warm the reaction. Photochemistry in the upper air can generate CH species that drift downward. In an ocean without oxygen, methane lingers and accumulates. Bubbles rise from seeps and burst at the surface with little fanfare. If anything breathed carbon dioxide and exhaled methane in those days, it would have found a world that welcomed the exchange. The rocks confirm only that methane had places to emerge and reasons to persist. Nitrogen's transformations left gentler hints. Lightning forged nitrates out of thin air, and rain delivered them. In certain sediments, trace minerals preserved ratios of nitrogen isotopes that wandered away from neutral. The shifts could come from thermal processes alone. They could also come from pathways that prefer one isotope during reduction or oxidation. The sediments from these times are too altered to promise certainty. Their whispers add texture rather than proof. They show that nitrogen cycled through more forms than gas and ammonia. They show a mobility compatible with eventual metabolisms that would build muscle from air. Time misled by sanding edges off all these possibilities. Heat blurred microtextures. Pressure erased pores. Circulating fluids moved elements from one lattice to another and back again. What remained resisted both full endorsement and clean dismissal. Debates sharpened around specimens that looked persuasive and around others that looked elegant but too easy to build without cells. Every candidate spoke through damage. Every interpretation carried scars. The only strong conclusion that survived repeating trials was that the planet offered abundant laboratories. It arranged physics to generate gradients. It organized geologies to concentrate feedstocks. It ran cycles fast enough to make many attempts and slow enough to allow survivors to endure. In experiments, glassware and metal imitate vents and pools. The products that accumulate under ultraviolet lamps overlap with those expected from prebiotic pathways that use minerals as catalysts. Nucleotides form when given the right precursors and dehydrating steps. Peptides grow from activated acids when surfaces align them. Lipids self-assemble into vesicles where salts lie within a certain range. None of this proves that similar products persisted in rock and sea long enough to meet, mix, and stabilize. It shows that chemistry leans in that direction if pushed and given shelter. Stones record the pushing and the shelters. Molecules that once used them as refuge rarely outlast the metamorphism that followed. Perhaps the most eloquent hints are negative. Nowhere in the oldest rocks do oxygenated minerals appear in formations that require a modern kind of air. Nowhere do thick beds of gypsum or anhydrite announce a sulfate-rich ocean. The absences narrow the range of worlds consistent with the record. They point to a chemistry that would be tender to certain metabolisms and indifferent to others. They suggest that if a lineage took hold, it would have learned on gradients of iron and sulfur, on the edges of pH, on films that dried without baking and rehydrated without dissolving. The story does not claim a caste. It describes a set of costumes and a stage direction. A quiet outcrop offers a final image. In the cross-section of a fine bed, a lacework of dark minerals threads through a paler matrix. Under a microscope, the lace divides into granules, aligned along curves that repeat with small deviations, as if a soft mat had once heaved and shaped the grains, then stiffened. Adjacent layers bear soft sediment folds that imply push and slip while still wet. Above, a thin seam of iron-rich material accents the top like a drawn line. The features together compose a paragraph that a future reader might translate as growth and trapping and binding, or as current and flocculation and settling. The difference is the presence of intention, which rocks cannot know. They offer possibility with an accent of familiarity. They tempt verdict and evade it. Twilight draws a veil over the outcrop. A breeze lifts and spreads dust into the last light. A distant vent mutters, a low note under the regular breathing of the tide. In pools along a nearby shelf, films retighten as water recedes. Within those films, chemical ambitions stir again. Whether they ever learn to remember in that age remains unwritten. The ledger keeps balance sheets, not biographies, yet even a balance sheet reveals a business underway. The planet supplied reagents, gradients, cycles, and shelters. The rest would be decided by chance, multiplied by time. The stone nods, patient and undecided. Recreation began in rooms filled with quiet machines and lights, the color of clean ice. Inside vacuum chambers, early atmospheres were rebuilt from gases met along volcanic coasts and vent fields. Carbon dioxide, nitrogen, water vapor, methane in cautious doses, sulfur compounds in traces, all admitted until sensors hummed agreement. Lamps poured ultraviolet across the mixture, while spectrometers watched the sky in miniature. Haze bloomed in glass as it might have in ancient air, tholins drifting like fine smoke, their optical fingerprints measured line by line. The result strengthened a portrait of light diluted, of horizons washed in copper, of a sun filtered by homemade clouds. On benches nearby, flat trays held thin films of brine, laced with salts and metals gathered from basalts and vents. Fans and heaters drove cycles in temperature and humidity, mimicking strings of windy afternoons and cool nights. Tidal rhythms arrived from pumps that pushed and withdrew water along schedules set by a lunar clock turned mechanical. Ultraviolet lamps strobed in doses adjusted to haze or cleared to sky. Instruments tracked pH, redox, and concentrations of small organics as they climbed, fell, and regrouped. Microfluidic chips etched with forests of hair, thin channels served as porous rocks. Across their walls, gradients in acidity and voltage established miniature geographies where reactions learned patience. The chips taught surfaces to behave like minerals, to escort electrons, and to hold brief alliances among carbon chains. High-pressure rigs addressed stone. Diamond anvils pinched powders of olivine and pyroxene while lasers read their structure at temperatures hot enough to make furnaces jealous. The minerals softened in measurable ways as water penetrated their lattices. Viscosities fell, convection hastened, and the balance between drape and dive could be mapped across a plane of temperature and hydration. A separate set of experiments melted komatiitic compositions and watched them glide in flumes, recording speed and cooling to find how far such lavas could run, how long before pillows would grow, how often a single eruption would reach the sea. The numbers fed models that tuned the tempo of resurfacing and the supply of metal to shorelines. Impact laboratories composed their own chaos. Light gas guns launched projectiles at targets fashioned from ice, stone, and salt water in layered combinations meant to mimic an ocean above a fractured crust. Sensors captured pressure waves, plumes, and ejector velocities. Some shots took place in chambers filled with early air mixtures, allowing ignition chemistry to right itself through the shock and aftermath. The resulting steam columns flashed into small weather systems within the chamber, complete with miniature rainfall. Glassy spherules fell out of the plume and layered themselves onto trays, just as their ancient cousins had sprinkled seas. Measurements of energy partition sharpened estimates of how heat seeded into basins and how long a crater would host its private climate. Elsewhere, biogeochemistry tried on possibilities without claiming conclusions. Flow reactors breathed hydrogen across carbonate chimneys, grown in tanks that assembled brucite and aragonite walls from alkaline fluids injected into acidic seawater analog. Pores matured into networks. Across their membranes, pH differences pushed ions like steady wind. Iron sulfide particles embedded in the walls conducted electrons across few nanometers, catalyzing reductions of carbon compounds into more complex forms. The chemistry grew wary of leaps and preferred steps, yet steps accumulated into ladders. Protocell vesicles formed when simple lipids met salts at the right range of concentration. They swelled, divided, and resealed without help, their membranes leaky to some ions and tight to others. None of this proved memory. It proved competence at building compartments and gradients. Climate grew inside supercomputers as carefully as crystals in a petri dish. Codes moved heat and moisture through virtual atmospheres under a star dimmed by a third. Aerosols were given spectra learned from chambers. Clouds were granted microphysics observed in flasks and in modern analog towers. Oceans kept their own time in coupled models that exchanged energy with air and tallied salinity, overturning internal waves and tides strong enough to rearrange entire basins. The faint sun paradox earned a family of solutions. Some runs favored methane haze with cooling at the top and warming beneath. Others leaned on cloud feedbacks that trapped infrared while reflecting enough sunlight to avoid runaway. Still others balanced weathering, outgassing, and carbonate precipitation to land the planet on a spine of stability. The codes did not agree perfectly, but they converged upon seas unfrozen and storms prolific, upon long days of calm followed by violent hours, upon climates that could be tipped by small changes, yet returned to center with stubborn grace. Magnetism also learned to live in numbers. Spherical shells of virtual iron spun inside numerical mantles that fed heat unevenly through their bases. The simulation's fluid obeyed equations that never relax and always surprise, building columns and helices that twisted field into existence. Reversals came and went, sometimes clustered, sometimes solitary. Magnetic intensity waxed and waned in step with boundary flux and with the squirms of liquid metal under rotational constraint. When the model atmosphere met the model magnetosphere, charged particles drew curtains in electric green. Transport rates of light gases fell under the field's supervision, as they must if oceans wished to endure. The calculations did not poetize, they budgeted. Geochemistry bridged scales by comparing what models predicted with what crystals remembered. Zircon diffusion told stories of how long a grain can hold its secrets under given heat, placing limits on metamorphic episodes and on temperatures inside crusts built in early time. Hafnium and oxygen ratios mapped sources from mantle to felsic domes and wove timelines from pulses of reworking. Models generated histories where drips pulled roots down or where slabs descended in short arcs. The histories that best matched the zircons were kept. The others stepped aside. No trace element spoke alone. Titanium thermometers, inclusions that whispered pressures, rare earth patterns that traced melt paths, all added discipline to the theatre of possibility. Optics entered the rehearsal hall with telescopes turned toward other suns. Planets silhouetted their air across distant stars and left spectral fingerprints in the light they stole. Some wore haze, scattering short wavelengths, as if made in similar workshops. Some presented with thick carbon dioxide envelopes warmed by their parent stars. A few swam in orbits where water should be liquid if pressure held. Their details remain slender, but they do not resist comparison. They are mock Earths, in the sense that they test ideas about scattering, greenhouse balance, and magnetic protection. Observers built worlds in code that resembled those dots of light, then dialed parameters until spectra aligned. The same codes adjusted back to this planet's past and proposed sky colors, UV burdens, and cloud decks that felt true to the physics and modest to speculation. Wave tanks etched with basalt tiles hosted scaled tides driven by paddles set to lunar timing. Films of organics, blown off stock solutions into windrows, collected along Langmuir streaks and were pushed onto polished rock as every cycle crested. High-speed cameras watched films ripple, wrinkle, and heal. Measured concentrations of chloride and magnesium altered how long membranes held before tearing. UV lamps brightened and dimmed, according to cloud data from the climate codes. The physics of lines in foam became a laboratory in which microlayers gained and lost fragments. The results returned to ocean modules in the climate runs through parameterizations usually left as guesses. Impact craters were rebuilt in sandboxes with rotating tables under them to simulate planetary spin. When projectiles struck at oblique angles, ejector patterns favored certain sectors. Wind fields seeded by the heated plumes bent distributed fallouts into asymmetric blankets. Those blankets matched unusual layers in terrains that keep old scars. The match suggested that some distant beds of spherules belonged to shallow seas shifted by wind and tide after the blast. The reconstructions then fed back into global models as temporary canopies of dust and aerosol. Sky brightness and surface heat flow adjusted for months to years, building an inventory of climatic aftershocks. Pressure vessels held seawater against blocks of peridotite at temperatures adequate to drive serpentinization. Hydrogen output was measured hour by hour. Alkalinity climbed. Membranes of carbonate thickened and peeled. A second set of reactors ran iron sulfides across similar chemistries and compared their voltages. Microelectrodes mapped gradients inside wet stones. Some runs added cyanide in parts per million and watched nitriles appear. Others supplied phosphate and borate in river-like proportions and watched sugar chemistry behave for a time before dissolving into noise. The chambers taught humility. Yields were low, paths kept diverging. Yet when the flows were intersected rather than isolated, a few products persisted across multiple environments long enough to be called robust. Machine learning roamed this workshop in search of needles. Wide parameter spaces burdened coupled models. Atmospheric compositions, solar variation, cloud nucleation efficiencies, haze particle sizes, ocean mixing lengths, tidal dissipation coefficients, eruption frequencies, sediment supply, all could be tuned within ranges constrained by physics and sparse rock evidence. Learning algorithms explored and returned families of states that satisfied boundary conditions and produced worlds that neither froze nor boiled. They found corridors where climate self-corrected and others where feedbacks amplified small trends. Those corridors became maps of plausibility. The maps did not bless a single path. They outlined a province. Paleomagnetism, once only a rock craft, leaned into the models too. Simulated fields wrote patterns in virtual basalts. Those patterns were compared with directions locked in real grains of magnetite carried in old river sands. Agreement or dissent retuned core boundary conditions. In turn, that altered auroral energy input to the upper atmosphere models and adjusted loss rates for hydrogen. The loop tightened. Tighter loops improved confidence that seas could hold their mass and that air could keep its greenhouses through tantrums of the parent star. A planetary chamber rose in a room the size of a gymnasium. Its walls were mirrors to lose heat quickly where needed, and heaters to add it where wavebands demanded. Within, a replica of a coastal flat stretched in basalt tiles and shallow basins fed by pumps that breathed tides to a schedule. Above, a sky of lamps adjusted from white to copper to pewter, following the daily spectrum calculated for a faint sun and a hazy air. Within this miniature world, dust lofted and settled. Rain fell from atomizers when clouds were called. Proxies of lightning lanced to selected spots. Films formed, tore, and reformed on the tiles. The chamber spoke in data and in spectacle. It taught how sensitivity hides in small settings, how a degree here or a tenth there composes weather and assigns chemistry to one basin or another. The work did not claim authorial certainty. It offered a union of constraint and imagination. Measurements from crystals and sediments told what must be true. Experiments told what could be true. Simulations connected could to must across distances in scale and ignorance. Together, they produced portraits that felt earned. A dim star overhead, a sky muted by haze and brightened by storms, oceans warmed by gases and stirred by tides, islands low and pale above belts of darker stone, vents that hummed and built gardens of pores, impacts that made short seasons of heat and rain, lightning that sketched chemistry and rapid handwriting, magnetism that painted night while preserving day. Evening in a laboratory can be as suggestive as evening on a coast. Screens fade to cooler palettes. Pumps exhale softer. The chamber's faux sun slides to red and contributes nothing to proof, everything to comprehension. A model completes another run and returns a world that looks workable. Stable clouds, liquid seas, green air free of oxygen, storms in rows, heat that enters and leaves in balance. None of it is the planet itself. All of it is homage guided by discipline. What matters is the accumulation of convergences. When independent lines lean to the same picture, imagination becomes inference. The ancient surface is still out of reach. Its shape, however, comes within sight. Two stories fit the same globe. One speaks of a mild sea under a dim star, clouds stacked like soft ramparts, rain cool enough to write rivers, islands low and pale cradling films that did not boil away. The other insists on a furnace, a skin of magma under steam skies, impacts that turn nights to day and seas to weather, an air thick as soup with a temperature not far from scalding. Both stories produce convincing maps. Both claim witnesses in minerals and models. The world carried evidence for each and refused to dismiss either. A temperate script begins with the stubborn liquidity of water. Grains that formed in deep time locked oxygen in ratios that point to low-temperature interactions with surface water, not flashes of steam over boiling rock. The chemistry of tiny crystals argues for early crust that weathered under rain, for runoff that carried silicates to basins, for rivers that did more than flash flood. The cool picture extends to cloud physics. With a faint sun, greenhouse gases must lean in, yet clouds can trap the right kind of heat at night while casting enough light away by day to hold temperatures in habitable ranges. A sky pasting thin, high veils can warm without suffocating, and a blanket of moisture can keep nights from plunging. The hostile script gathers heat from impacts and magma and global steam. Early bombardment supplied energy in single jolts large enough to vaporize oceans locally, and to fill air with silicate aerosols that glowed with their own warmth. crust young and thin-bled lava through countless fissures, turning broad provinces into firelit plains. An atmosphere loaded with water vapor, carbon dioxide, and methane would run hot until chemistry and rainfall could draw those gases down. Lightning and ultraviolet carved through the thickness, but neither cooled it. The world in this telling wore a fever, broken by intervals that never lasted long. The surprise is that both stories can be true without contradiction. Climate is a set of balances, and those balances can settle into distinct stable states under similar boundary conditions. With enough greenhouse gas and haze placed at certain heights, temperature fields can land on warm plateaus. With cloud feedbacks tuned differently, the fields can drop to cooler terraces that still resist ice. A planet can flip between states when pushed by impacts, by shifts in volcanic output, by changes in haze formations. Neither state holds permanent title. The globe moves among them like a pendulum confined by gravity to arcs that stop short of catastrophe. Geography allows both scripts at once. Hot provinces can thrive above plume heads, while cooler belts persist downwind under thick anvils. Basins shadowed by cloud lines can support rain-cooled surfaces even when other regions simmer. A crater lake can steam on one continent while a shelf sea wets a feldspar beach elsewhere under a lower sun that peak loads clouds in that corridor. Temporal patchwork is almost guaranteed. A planet with a short day and a nearby moon develops tides strong enough to stir heat in confused directions and to exchange warm shallows with cool depths on schedules that break uniformity. Add variable haze that forms above methane-rich areas and thins where ultraviolet or oxidation corrects it, and the map becomes a quilt rather than a blanket. Long feedbacks sharpen the reconciliation. When the world heats, weathering tends to accelerate where rain and rock meet. Basalts strip carbon dioxide from air quickly, building bicarbonate that flows to sea and eventually precipitates in minerals. The drawdown cools air just enough to curb the fever. When the world cools, weathering slows and volcanic exhalations, even if constant, accumulate in the sky, adding warmth. Clouds join the negotiation. Low decks reflect light and ease heat. High veils trap infrared and retain it. The balance moves in small tacks rather than sweeping turns. The outcome is persistence of liquid water through insults that should have frozen or boiled it under a stricter regime. The record of impacts seems to favor fire, yet it also offers islands of reprieve. Large strikes sterilize neighborhoods and turn seas into steam for weeks to years, then leave basins of long-lived warmth dotted with vents and terraces rich in metals. Between these events, flux drops, skies clear, and rains reclaim ground. The frequency curve matters. If blows arrive often enough, climate cannot take a breath and remains hot. If the intervals widen, the planet cools between insults and averages to temperate. Evidence suggests an early cascade of large bodies that thinned as orbits calmed. The consequence is a front-loaded inferno, transitioning toward restraint. The dim star paradox adds another layer. A weaker sun begs for stronger greenhouses, yet not so strong that it collapses into runaway warming. Models identify lanes where carbon dioxide, water vapor, and methane combine with clouds to keep seas liquid and air tolerable. These lanes widen if haze layers reflect sunlight slightly while adding a mild infrared blanket below. If haze grows too thick, it sends energy back to space and chills the ground. If too thin, ultraviolet burns chemistry to fragments and greenhouse windows leak. The real sky likely walked middles most days and stepped aside only during unusual episodes that show up in sediments as abrupt changes in mineral textures and in light absorption. Arguments over ocean temperature resolve into ranges rather than points. A basin with deep vents and little mixing can run warm below, cool at the skin under frequent cloud, then warm again in afternoons that pursue gaps between anvils. Shallow shelves can heat quickly in sun and freshen in storm. Polar belts, if they existed robustly, may have worn seasonal caps and leads that moved under tides, balancing Earth's albedo against the need to keep seas from locking. In all cases, the folding of heat into thickness and the dragging of cold into depth act as memory. Water resists change, so variance compresses, and the surface reads as moderate even when inputs spike or dive. The sediments do not insist on a single temperature. They exhibit textures that require both calm and violence. Thin clay laminations argue for quiet basins under mild weather, for stretches long enough to weave fine layers. Cross-bedding and graded beds inserted between them argue for storms of capacity large enough to restructure beaches. Chemical precipitates in even bands point to steady conditions that held for months or years, while layers rich in spherules interrupt that steadiness with signatures of heat that fell from the sky. Taken as a set, the rocks are less a vote for one scene, and more a journal of alternating moods inside limits that preserved the ocean. What emerges from reconciling the scripts is a concept of habitability that is neither fragile glass nor stubborn stone. It is a regional, seasonal, and episodic property. A world can be hot in places and times without erasing possibility everywhere. A world can be mild under clouds while not escaping the glare over bare water at noon. The delicate work occurs where gradients pile together, where temperature and salinity meet pH and redox under a clock convenient to molecules. Those crossroads appear in both stories, roaring furnace and quiet sea alike. The difference is not whether chemistry can proceed, but which pathways are favored and where. Exoplanet surveys give the reconciliation new company. Distant worlds show hazes, heat balances, and orbits that span the parameter space once available here. Some wear thick carbon dioxide skies under dimmer suns. Some show signals of scattering best explained by complex aerosols. A few live near star flares that rival the tantrums of a young Sunday. The lesson from those dots is simple. Multiple climate states can deliver liquid water if their pressures, gases, and clouds add up properly. Multiplicity is the rule rather than the exception. Consider a day captured by no eye. Morning opens on a coast where anvil shade keeps temperatures pleasant. Pools hold their films. Streams carry bicarbonate to a bay that precipitates a skin of carbonate along terrace lips. Far offshore, a plume blows incandescent over the horizon and paints the sky with dust that warms the night to come. Midday brings a break in cloud. The ground heats, the upper centimeter of sea becomes a kinetic manuscript written in glare, and UV punches reactions forward. Toward evening, a storm line crosses. Lightning stitches the tableau, and rain strips aerosols from the air. Night descends under a green belt of aurora, cools the skin of the ocean, and sets the stage for inversion fog at dawn. On the other side of the ocean, a crater basin steams, and a vent field along its ring makes pH batteries hum. Both scenes, mild and molten, occupy the same day without contradiction. The reconciliation delivers a more generous hindsight. It allows the planet to have burned and rested, to have carried seas through tantrum and calm, to have supplied both cold rain and hot brine, to have offered ultraviolet knives above and mineral salves below. It frees the narrative from choosing a single mask. The face of the world contained both. Its chemistry learned under both. Its stones memorize both. Night leans in, carries a smell of acid rain on warm rock from one quarter and a soot of volcanic ash from another. The ocean has enough heat to keep moving through the dark, enough memory to smooth the stars' mood swings, enough company in clouds to make mornings survivable. Cool story, hot story, one timeline. The ocean keeps time in liters and years. The air keeps it in droplets and hours. The rock keeps it in terraces and grains. The planet keeps it by refusing to be simple and succeeding at being stable. A planet stood within reach of its own breath and practiced the art of balance. Heat climbed from its heart through rock that flexed and healed. Light entered through a veil that changed by hour. Water stored the day like a disciplined ledger and returned it at night with careful interest. The world did not chase a perfect climate. It assembled enough stability to keep the ocean liquid, then filled the margins with weather and fire, with tides and dust, with calm that could last a week and storms that could last an afternoon. From orbit it looked muted yet intricate, a dark sea crossed by pale cloud caravans, low islands gleaming like chalk around belts of older stone, auroral stains at night that waved like silk pinned to the poles. Air wrote the first layer of the portrait. Nitrogen made the room. Carbon dioxide warmed it. Water vapor moved warmth around as packets of invisible freight. Methane appeared where vents and rock delivered it, then turned to haze when sunlight pinched its bonds. Sulfate particles formed from volcanic breath and lifted brightness into thin decks. Blue existed, but seldom dominated, hidden under milkier scattering. At noon, the sun often resembled a coin edged with light, polished by ice plates high above. At evening, colors tilted toward copper and gold, and then faded to a green wash of airglow. The atmosphere never stopped calculating. It weighed reflection against retention, changed cloud altitude to tune the answer, accepted trace gases, and returned weather. C completed the second layer. It ran deep and iron-rich, a dark reservoir with a skin that behaved like a living instrument. The first millimeter governed exchange between worlds, letting heat in, letting gases out, sometimes reversing those roles when temperature flipped. Wind combed the skin into rows and lanes, narrow rails where films gathered and broke into slick ribbons. Beneath, temperature beds stacked into floors that internal waves wandered. Over sills and ridges, tides pushed cold upward and tugged warm downward, erasing sharp borders and preventing stasis. Hydrothermal fields planted gardens of pores along ridges, and those gardens exhaled heat and metals into plumes that lost color with distance but not effect. The ocean spoke softly in chemistry and loudly in movement, both voices tied to clocks in the sky and clocks in the crust. Rock provided the third layer, stability with seams. Basalt paved wide floors. Pale domes of more buoyant stone rose where melts separated and slowed. Greenstone belts curved around those highs like rivers of altered lava. Dikes and sills stitched the map with black ribs, memories of pressure that found relief. Detachments allowed blocks to glide. Sag belts invited cool descent that fed hot return. Dripping roots pulled heavy packages away and let lighter crust float higher. The surface was low but durable, enough for rivers to develop habits, enough for basins to keep diaries of storm and stillness, enough for weathering to borrow carbon from air and place it in stone. A companion ruled the periods. The moon rode close and heavy, tugging not only at water but at bedrock. Tidal bulges walked the planet twice a day and translated gravity into chemistry. Pools filled and emptied to precise rhythms, concentrating brines and then forgiving them. Currents accelerated through straits and turned chaos into mixing that mattered. Internal waves collapsed along slopes and released veils of suspended dust that fertilized the next quiet patch. The moon also tamed the wobble of seasons, narrowing extremes and lending the climate a steady beat against which shocks could be absorbed. Eclipses cooled patches of ocean by fractions, then ceded control as immediately as they had taken it. The sea remembered those small changes and stored them for hours that mattered. An engine at depth wrote the background. Liquid iron turned in darkness and dragged magnetic field lines into loops that pinched and stretched. The field caught the star's wind before it stripped the upper air bare and redirected energy into curtains of light. In those displays, the planet showed a sign of its interior, a night-long handshake between core and sky. Protection was more than spectacle. It was time granted for oceans to persist, and for surface chemistry to repeat attempts that would otherwise have been erased. Violence visited without apology. Large impacts released seasons of heat in single hours and left craters warm enough to host special weather for years. Flood basalts reset geography and challenged air chemistry. Ash veils, steepened sunsets, and altered cloud decks. Yet after each insult, rain resumed its arithmetic. Rivers cleared the air and carried new ions into basins. Vents rebuilt their terraces. The magnetic shield pressed the storming star into forms the lower air could tolerate. Warmed oceans gave up heat at night and kept the next morning from beginning in shock. The long average leaned toward habitable, even though no mind measured the average and no creature asked for it. Chemistry turned the portrait into practice. Brines traced out electrical gradients along mineral walls, pH fronts crossed in pores, and made batteries as thin as a hair. Films tightened and loosened as tides swung. Lightning wrote oxidants into droplets that kissed the sea and changed what sank and what stayed. Phosphate trickled into pools from meteor alloys and basalt. Ammonia drifted in from lightning and rock-water reactions. Cyanide appeared in trace quantities where ultraviolet nudged nitrogen and carbon into the same corner. Membranes formed at carbonate chimneys, messy but selective, and protons fell across them the way rocks fall down slopes, willing to do work if a path could catch them. The ocean favored no story of life. It favored reaction paths that fit the gradients it kept rebuilding. Light framed the day like a sequence of drafts. Morning arrived pewter, then brass. Noon ranged from white to washed. Afternoon leaned toward amber under anvils, or toward glare where sky windows opened. Evening performed optics that read like instruments, halos for crystal sizes, pillars for crystal shapes, green flashes for thermal staircases layered in air. Night returned, a dim green horizon line, and a moon road broken into dashes by chop. The show was not decoration. It was the visible side of budgets tallied in watts per square meter and in joules stored per kilogram of water. Beauty coincided with function. Silence, when granted, was the subtlest teacher. After a storm, a basalt apron steamed while a shallow lake cooled by degrees. Mist collected along a low sill and poured like a fluid, then vanished as gravity found it. Salt crusted in tiny arches and collapsed at a fingertip that did not exist. Films held long enough to wrinkle. Pools sorted themselves by depth, each with its own pH and temperature, each with a different invitation to dissolved carbon. Under a sky gone suddenly thin, ultraviolet sculpted another hour of products. Then cloud thickened again and put a lid on the kiln. The planet did not pause, it ratcheted. In a single imagined panorama, the portrait resolves. On the far horizon, a plume from a ridge draws a dark thread into the sky. To the left, an island of pale rock shoulders out of darker schists and carries fans of bright sand where a river braids into the sea. In the foreground, a tide flat shines, gridded by polygonal cracks that catch thin films, their edges bright against hairline shadow. Above, anvils lift and shield long lanes of water, inviting streaks to form and carry foam into convergences. Beyond them, a gap admits a column of sun that drills a single stage onto the surface, a spotlight under which reactions hurry. To the right, a boar climbs a channel and scatters pumice onto a ledge it has not reached in weeks. Over all of it, a pale disk rises and pulls the ocean against itself. At night, a green curtain lifts and plays across the dome, then fades. In the morning, the same place looks different by small degrees, enough for a new set of outcomes. The world did not choose a destiny, it chose behavior. Retain enough heat to keep water free to move. Offer gradients in abundance. Permit weather to rearrange the palette often. Allow rock to keep records. Handsome advantages made the improbable common and the delicate robust. The surface, to an eye, might have looked alien, heavy with metal colors and filtered lights. To an equation, it looked hospitable. To a molecule, it looked busy and patient. That is the shape of the dawn, not a single panorama, but a discipline. The planet lived by rules generous to complexity, and in that generosity lay the sanctuary where time gathered courage. He looks down without eyes and counts the colors that do not exist today. A sky of pewter and coin, an ocean of bottle green, a moon so near it pulls breath, a curtain of light that writes the signature of iron on night. The world is a vessel of warm water lifted toward a modest star, its rim glazed with cloud, its interior stirred by a clock that ticks in tides. Rock hums underfoot like a choir of slow bells. Air tastes of wet stone and acid, then sweetens by a degree with rain. Light arrives like a careful hand. Heat leaves like a prayer. He listens and hears numbers hiding in weather. A ripple of foam counts hydrogen ions across a film. A thunderhead measures latent heat in towers that breathe. A vent negotiates with chemistry in words of voltage and pH. Pools recite their tides. Drips in caverns keep another ledger. The planet remembers in crystals, in laminations, in the way a terrace steps down from a spring. He trusts the machine. Gravity pulls, rotation sorts, conduction whispers, convection climbs, radiation balances, and the sum is a day that does not break. Nothing here asks permission to be beautiful, yet beauty arrives as a side effect of order that refuses perfect symmetry. That asymmetry lets chance speak. Chance speaks often, time answers always. He closes the circle with a feeling that has no witness. The dim star lifts, sets, returns. The ocean holds, releases, holds again. The air trains light and gives it back. The ground builds, collapses, builds again. In this rehearsal, the improbable learns the shape of home. A world without eyes becomes a mirror for futures. The stage is ready, the curtain is light. The orchestra is weather. The audience is time. End of script. Sweet dreams.